over some of the strategies. Pay careful attention as we go along, just in case you didn't understand something, so you can see how you get the full marks. And so first thing, this was what we had went over last class. I did not feel comfortable because I was out on Tuesday to give you a mini assessment today. That's why you don't see it on the schedule. It's going to be on Monday, and it will definitely include this topic. So if you've got hot concentrated MnO4 minus, this means that you have an oxidizer. It's an oxidizer. Some students mentioned that there were some questions with K2CR207, the homework that's due tonight. K2CR207 actually acts just like MnO4 because it has lots of oxygens as well. But I also told all the students who asked that if you wanted to just not do those questions until we cover it on Monday's lesson, because that's when we're going to do the alcohols. Remember, I told you that I was going to try to do alcohols that day, but I stopped to give you some time to brain break to study before the mini assessment. That topic had K2CR207 on it, so we're going to cover that on Monday. That was scheduled for Monday's lesson. Therefore, if you want to skip those questions with K2CR207 and submit your homework without those questions, I'm fine with that. You can still get full credit on the homework, just doing the ones that are KMNO4. But just so you're aware, K2CR207 oxidizes the same way KMNO4 does because it has lots of oxygens. So it's the same idea. However, so to solve this, you would break both bonds because it's hot. The H2SO4 was just acid, right? That's just to tell you it's acidified, KMNO4. They're not showing the potassium because it's a spectator ion. They don't have to show it. And so it splits it, and you were supposed to add the oxygen to each side. And so you should notice here that this is a ketone, and this is an aldehyde. But aldehydes don't stay aldehydes. Aldehydes always become carboxylic acid. So this would be your answer. This is worth 1 mark, and this is worth 1 mark. 1 mark for each correct product here. So just so you're aware of how that works. All right. Any questions with this, or are we okay so far? I see some of you are writing it down. We're going to go and we're going to look at that mechanism again. We're going to look at this mechanism again later when I review the mini assessment too. This mechanism is one of the 5 you need to study. I told you I think it's mini assessment 8 or 9. It's one of the last ones where you're going to have a mini assessment that's just on mechanisms towards the end of the unit because you need to practice and you need to study mechanisms. And so you should be reviewing those. I'm not going to put another mechanism on a mini assessment yet, but I'll let you know when you have a day that you have a mechanism on a mini assessment, just like I did last time. All right, let's take a look. This is what type of mechanism? Can anybody tell me the type? It's not free radical. There's no, it's addition. It's called electrophilic addition. Because it's the electrophile that adds first. And so just to remind you on the strategy, you are first supposed to start with your dipoles, H and Br. What are your dipoles on H and Br?
H positive, Br is negative.
H positive, Br is negative. So far so good? Then here's where most people are going wrong. And we're learning mechanisms again today. You should see if you keep your schedule, the schedule that I'm following, today it says we're learning the mechanisms of the reactions you went over last class. So there's a reason I'm teaching this again. Like re-going over it because you need to understand how mechanisms work. The curly arrow always starts at a pair of electrons. So write that down if you need to. The curly arrow always starts at the pair of electrons, not at necessarily what you're adding. It starts at a pair of electrons. A lot of people made a mistake with that on the last mini assessment. So in this mechanism, the pair of electrons that starts it is the pair of electrons of the double bond. That's the pair of electrons. The double bond breaks, and the pair of electrons basically swings out to grab the hydrogen. But hydrogen is currently bonded to bromine. So in order for hydrogen to instead be bonded to one of these carbons, this bond has to break. So you have to show that bond breaks, right? and at a pair of electrons goes the bromine. So far, so good? Right now, because of how the marks were distributed, we have right now one. One for the dipoles and the curly arrows. The next mark would be in the intermediate. So the intermediate here, you would have to note, and I saw some of you going to start writing it in skeletal, and you could do that. That works, you could. But I'm going to show everything because I think that that's the best way to go. And so you would show this, you would show this. This is the carbocation, the one in the middle, and then here you've got the C, H, H, H. The hydrogen adds to the end, and the carbocation is the one in the middle, right? That's where we're at so far. What else is my other product? So this hydrogen got added in. What's my other product right now? Plus Br minus. I highly suggest, because almost none of you did this correctly on the mechanism that I gave you, that you write all the pairs of electrons that are there, because some people are writing one, people are writing none. Write all the electrons. You have to write two, but I do suggest writing them all to show octet row being satisfied. Then, right now, this right here, this intermediate correct is the second mark. So right now we've got 2. The next thing is you've got to show the arrow coming from the pair of electrons. So you can circle the pair of electrons if you want to show that. You don't have to. But you've got to show the arrow starting at the pair of electrons and ending at the positive charge. Because it's the 2 electrons that are making the covalent bond. This is the third mark. The fourth mark is the correct final product, actually. So if you give, however you do it, CH3, CH, and this is Br, and then CH3, this is the fourth mark, is the final product. So that's the fourth.
Oh,
Because they didn't show you what the final product was. So the final one. Because the mechanism is how it happened. If you're only writing the final product, you're not giving the mechanism. You have to show the story of what happened. What bonds are broken, what bonds are formed. Mechanisms are really important to study. All right, 2 marks on why the 2 bromoalkanes you could get are not produced in equal amounts. And so 1 mark is to say that the secondary carbocation is what? The secondary carbocation is more stable than the primary carbocation due to what? Due to inductive effects of neighboring carbons or neighboring methyl groups. I'm going to say neighboring alkyl groups because it's just methyl ethyl. I don't have to specify. So the idea is that the secondary carbocation has these carbons on the side that stabilize the positive charge. If we had the carbocation on the end, there would be only 1 carbon on the side and then a hydrogen on the other end, so it's less stable. And so the most stable version is the one that's most substituted, is the idea. But that's the explanation. You have to explain inductive effects, or something that says that the carbons surrounding the carbocation stabilize that charge. Secondary carbocation is more stable than the primary carbocation due to inductive effects of the neighboring groups. So this is more stable than if you had this. If you had that, that's not this stable. All right, Bower 3, the last part of the Bower. This is from last class's lesson. I was testing to see if you remembered what that was. Last class's lesson on the ed puzzle, you learned about nucleophilic substitution, which all of these, OH minus is a nucleophile, Br minus is a nucleophile, and Cn minus is a nucleophile. So these are all nucleophiles substituting for each other, and the answer here is C. Free radical substitution is a hydrogen for a halogen. When a hydrogen swaps with a halogen, that's free radical substitution. That happens to specifically alkane. So it's whenever a hydrogen swaps with a halogen. And then electrophilic substitution doesn't even exist, by the way. That's not a thing you're going to learn.
Addition, right?
It's electrophilic addition, right? So that's not even a thing. So it can't be A or D. And so it's really just between these two. And free radical substitution is a hydrogen swapping with a halogen. And that's not what you're seeing here. And so before we get into today's lesson, I did want to go over, I hope you wrote your flashcards out last class. Turn it on, please. I hope you wrote your flashcards out last class. I'm going to do a quick review of the types of reactions we studied, or that you studied last class, nucleophilic substitution. And because we're going to do the mechanism today for it. So, first of all, what's a nucleophile?
Negative charge.
But it's actually any substance that can donate a pair of because not all nucleophiles you studied last class were negatively charged. The examples of nucleophiles you need to know about. The nucleophiles that you were asked to know last class were CN minus. Where's the pair of electrons with CN minus? Do you know? The one that's being donated? It's on carbon.
Oh.
It actually extends the carbon chain. That's an important note. So you may want to write that out. OH minus. On OH minus, where's the pair of electrons that's being donated?
Hydrogen.
Oxygen. Right? NH3. Where's the pair of electrons being donated?
Nitrogen.
Right? And I believe there was one more. Was it water?
Yeah.
Did you have water? Where's the pair of electrons on water?
Oxygen.
On the oxygen, right? So what links all of these together as nucleophiles is their ability to donate a pair of electrons. And so a nucleophilic substitution is one nucleophile swapping with another one. And so I wanted to give you just a couple of example reactions before we go over the objectives, just to review if you've got the idea. So you're going to want to write these down. So let's start with this one. CH3, CH2, I plus OH minus and AQ and heat under reflux. Hopefully you made your flashcards, you have your conditions. Those are the correct conditions just in case you need it. What happens here?
The I swaps out for the OH.
Right. Because when iodine gets kicked out, it's going to get kicked out as I minus. And then the OH takes its place. So I is what we call a leaving group. It's weak, it gets out. And OH takes its place. This is not a mechanism, so I don't have to show exactly how it happens, but we're going to do it today.
Do we need to put heat under reflex, or do we just gonna try and?
You should put under reflux. So plus I minus. Just swap them, right? That was the first one. The next one was, and I'm going to do this one skeletal. I know some of your favorites. Let's do Br plus Cn minus, and then ethanol and heat. Solvent is ethanol and heat. What happens here? What's the product? Products. It's a swap. What's getting out?
BR.
What's getting in?
CN minus.
And it connects at the carbon is the important thing to know. So it's going to become this, and then this is another carbon. And you could write the C, or you could write it out like this. Right?
Yeah.
Because C triple bond N, that's what it is, isn't it? In case you need to know.
Yeah.
That's what it is. It could show like that.
For the nucleophiles, they're always stronger than the halogens.
They're stronger than most halogens, except I would say not fluorine.
Fluorine is the strongest.
Fluorine is the strongest of them, yeah. So typically a reaction will not happen, or will happen in very low quantities with fluorine. Cambridge typically tests only chlorine, bromine, and iodine for that reason. I've never seen them put fluorine, like as one to get picked out
And
for that reason.
swap with those three.
Yeah.
How do you know which one is strong?
You don't have to make that prediction. If you were to study a further study in organic chemistry, like in the, no, further than A level, like if you were to study at a university for organic chemistry, then you would have to make that prediction. But even at the A level, you really don't have to make that prediction.
They'll
Here,
always
they're
do
just
nucleophiles.
assume that it's gonna happen.
They're always doing halogens nucleophiles then?
And then, because these are reactions of halogen alkanes, that's what we're studying. And so, then the last one that you were supposed to know last class, so I'm writing it out, is this one. We did sign it, oh, NH2. So we've got Cl plus NH3. And this is the one that's high pressure, which is what you have to remember about ammonia. So they highly pressurize it, yes.
Question for the CN, where does the BR go?
Oh, it's still there. So it's just Br minus, thank you. Now what about this next one?
You swap out the Cl for the NH3.
Now you gotta be careful here, because this one actually, instead of giving you NH3, gives you NH2. And so here you would get NH2 and HCl as your byproduct. Because the H gets kicked out with the chlorine. Kind of like the fourth place of salts.
Okay.
So this right here is called an amine. You make an amine. In this reaction, you go from a halogen alkane and you turn it to an amine. So the idea of a nucleophilic substitution is you've got something negatively charged, picking out something else that would be negatively charged or have a pair of electrons. Julio, question.
Why does it use that?
For which one? This one?
Yeah.
It's just the conditions that are required for it to get on.
Like each of them have their own conditions.
Doesn't have it in aqueous.
Oh,
Oh, wait, it does have it in aqueous.
Don't go those.
NH2 is under pressure.
And then they're all, yeah, NH3 is under pressure.
OH is
FN, no. Not FN, sorry, aqueous.
the other one was heat under reflux.
The OH is.
Heat,
All right,
OH
so those are the things you should have on your flashcards from before. I just wanted to do a couple of example reactions. We're going to be looking at these specific reactions more in detail today because we're going to be looking at the mechanism. And so today we are going to learn two mechanisms. Look at the objective. So now we're ready to read the objective. You'll see that it's only two. What does that mean? There's only two objectives.
so hard.
All right. So candidates should be able to 16.1.5 describe SN1 and SN2 mechanisms of nucleophilic substitution in halogen alkanes, including the inductive effects of alkyl groups, which is the same thing it was before. Inductive effects are the same thing. We'll talk about it again in the lesson today. 16.1.6. Recall, that means just know, right? Know that primary halogen alkanes react via SN2, tertiary halogen alkanes react via SN1, and secondaries are a mixture of the two. Go ahead. Yes. Okay, so we've got two mechanisms to cover today. Altogether, there's a total of 5 we need to learn. We did free radical substitution, that was number 1. We did electrophilic addition, that was number 2. Today we're doing SN1 and SN2, which are actually number 3 and number 4. And then we'll have one more to learn, which we're not going to do until, I think, 2 weeks from now.
Oh.
We're going to do the last one. So you'll know most of the mechanisms after today that you need to know. So let's get to it. Mechanism of nucleophilic substitution in halogen alkanes. Some important things you need to recall. Nucleophiles are donators of electron pairs. No electron pair, not a nucleophile. So we said NH3. What else?
Cyanide.
OH minus. Water, thankfully, you don't really see a mechanism for that. And I don't remember if you go back to your notes from last class when you went through the standards, they'll tell you they're looking for OH minus, CN minus, NH3. They don't even have water in there anymore, like in the standards, in that one. So NH3, OH minus, and the other one is CN minus. So these three you absolutely got to know. These are your three main nucleophiles that you would need to show in your reaction.
They will give it to you, right?
Yeah, they'll have to tell you. Other than that. Or state, it's a nucleophile. Or have a pair of electrons there. But these are the ones you're going to see. So there's two possible mechanisms, unfortunately. And you're going to have to pay careful attention because you're going to have to make the decision on which one you're going to need to use. Whether it's going to be SN1 or it's SN2. And the one we choose depends solely on what does our halogen alkane look like. What do I mean by structure? Whether it's a primary halogen alkane, a secondary halogen alkane, or a tertiary halogen alkane. So before we go on, because I like to have fun with this. Primary, secondary, or tertiary halogen alkane.
Secondary.
Secondary. The carbon that has the halogen is attached directly to two carbons. All right, another one. Primary, secondary, or tertiary halogen alkane?
Oh.
Primary, right? Primary, secondary, or tertiary halogen alkane? Tertiary. So what they said in the standard is that the mechanism of how a substitution will happen with this compound differs from how the mechanism will occur with this compound. And then if you get a compound like this, you could get both mechanisms. Now, thankfully, I have never seen them tested, like show both possible mechanisms. I don't think it's impossible if we look at the standard. It just says to recall it. So it's not impossible, I don't think. If it's a secondary, to ask for both mechanisms, both potential mechanisms. But I've never seen it in a question before. That doesn't mean it can't happen. All right, so let's first talk about what happens to primary halogen alkane. We call it the SN2 reaction. So first of all, what do these letters mean? Why do these letters mean what they mean? We're going to discuss that now. So you could just memorize that an SN2 mechanism only happens to primary halogen alkanes and secondary halogen alkanes, but never to tertiary halogen alkanes. What does SN2 stand for? It's so silly that it's called nucleophilic substitution, but then it's SN instead. So it's substitution for S, nucleophile for N. So the letters are backwards, but that is what it is. And then 2 means that the rate of the chemical reaction. What? The rate of the chemical reaction both depends on the concentration of your halogen alkane and the concentration of your nucleophile. What does that mean? This is the important part here, right here, because that's the 2 versus the 1. If I change the concentration of the halogen alkane, I will change the rate of the reaction. So if I have more concentration of halogen alkane, meaning I have more of it. Concentration we know is moles over decimeters cubed. So if we have a greater concentration, if we add more of this, the reaction is going to happen faster. So far, so good? We'll talk about why in a little bit, because the why is the mechanism actually. If I increase my nucleophile concentration, which here would be my OH minus in the example reaction I've written. This also means the rate of reaction is going to go faster. So what the 2 means is that whether I add more of my halogen alkane or if I add more of my nucleophile, changing the concentration of either of these is going to make my reaction go faster. And the mechanism will answer why, because we're going to study the mechanism. What? Oh, RXN stands for reaction. When you run out of space and don't want to write anymore, you write RXN for reaction. 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 Friction.
What do you need two pencils? What do you need two pencils?
I'm pausing. So this right here is a favorable reaction because OH minus is a stronger nucleophile than Br. Generally speaking, all the nucleophiles that were presented to you, OH minus, NH3, and CN minus, are stronger than almost all of the halogens except for fluorine. So you can assume that the reactions happen in good amounts. Yes. Yes. I'm giving some pause. That's a good question. I'm trying to think. Let me look at some extra mark schemes. What did he ask? Could you use RxN on a Cambridge exam at the same time? Like, I feel like that's such a commonly used abbreviation by chemists, but I don't know if it's an American chemist thing or an international. Like, I don't know if it applies internationally. I know that it applies in all my American courses. Let's get back to you on that one. Let's go hesitant for now. Hesitant for now.
What was the thing you said? There's like I for
In effect.
I
Oh, yeah.
we can't use that.
You can't use IMF for intermolecular forces.
Oh,
That's the one you can't use. Because intra is also IMF. That's why. Give me those pencils back. Well, which are mine, right?
Yeah.
Those look like my pencils.
Yeah, they are.
All right, so let's take a look at the mechanism. Why does the rate depend on both concentrations? Let's take a look. What happens in the first mechanism, and yes, I am apologizing for the diagram that I'm looking at right now. The person who made this online is wrong. The arrow should start at the pair of electrons, right? So fix that on yours. Because I know that if you're studying, you may accidentally do it wrong on a quiz or a test. So that OH minus starts the reaction. And what happens is OH minus is a nucleophile, right? So it wants to find what? What does a nucleophile want to find? What does a nucleophile want to find? Something that's negatively charged is looking for something that's negatives and negatives? Looking for something positively charged. And so what's going to happen is in this halogen alkane, the carbon's partially positively charged and the halogen's partially negatively charged. It's what we call a polar bond. And so the OH minus, those electrons go seek out that carbon. But here's a problem. Carbon already has, I have this up here and some of you still not give me carbons with 4 bonds on your mini system. Bringing it up over and over again. Carbon makes 4 bonds. 4 bonds. No more, no less. So,
Like with double bonds?
if this OH minus is here, you can't make this 5 bonds, so something's gotta go. Is it the hydrogen or is it the bromine?
The bromine.
The bromine goes. Because it holds its negative charge much better than the hydrogen. You're gonna give hydrogen a negative charge? It's not normal. Bromine being more electronegative, wanting the electrons more, is the one that's going to take the electron. And so this goes, and then the bromine leaves. And the bromine's gone. This is what we call a transition state, a less than millisecond moment of time that you have all 5 bonds. But notice, it doesn't really because these are dashes. So it means as this is coming in, this is going out. So that's why they're dotted lines and not pure covalent bonds. And we call this the transition state. And so you might see this on a paper 1, and you have to know that it exists for SN2 reactions. As the OH is coming in, the bromine is leaving. But typically, I've never seen you have to draw one yourself on a paper 2, but you do have to know of its existence for a paper 1. And then this would be your final product. And what's the other product they haven't drawn here? The Br minus, right? So that would be the other product. Milliseconds. Millisecond. Less than millisecond time where you have all 5. Like, as this is going in, the other one is going out. And so, I wanted to show a paper 1 question. This is what I mean by they could ask about the transition state on a paper 1. They ask you, phenacyl chloride is reacting with aqueous NaOH. They tell you it follows SN2. Which structure is a species formed during the reaction? So they're asking for the intermediate. So the idea is that the OH minus is going in, right? And the chlorine would be getting out. The OH has what type of charge? Negative. And the chlorine would also be? Negative. So it's base. What's the problem with D? Why not D?
Because it makes the carbon negative.
Carbon is not
What do you think?
negative.
Carbon is positive always.
Carbon is positive.
Always.
Yeah, exactly. Carbon is not going to be partially negative. It's going to be partially positive when it's put with negative things.
This was the thing that had to do with them being bigger or smaller, like the atoms.
The inductive effects? Are you talking about inductive effects? That's coming later. What?
Why is it different?
Because it's an overall -1 charge.
Oh, it's all just.
That's what that means.
And it's supposed
That
to be like that,
It has an overall -1 charge at the moment, because that's partially negative, it's partially negative. Being an electron, the electron being will go somewhere like this, yeah? But they're dashed. They're not regular bonds. All right, so let's show this mechanism. Where are the marks? This mechanism, if this shows up on your Cambridge exam, is worth the least marks of any. It's typically worth 2. 2-mark mechanism. Which means it's the easiest mechanism, but easy in can also mean easy out. So it says we are going to do 1 chloropropane, and what are we reacting it with?
Alkali?
CH3, CH2. I'm going to expand around this final carbon for the mechanism. I like to call this the carbon of interest. This is not a Cambridge word. This is a me word.
Actual exam.
Expand around the carbon of interest, you can do that. If it's a mechanism, yes. You could do structural until you get to the one that matters. You'll see them do that sometimes. Doubt.
I just put a skeletal.
All right, so carbon of interest is the one that has the halogen, right? And so the reason why I'm expanding all the bonds around the carbon of interest is to show octet, is to make sure that everything works out the way it's supposed to. And so, what is this reacting with? What do they tell you? What's alkali? What's alkali? It's another word for OH minus, base. It's another word for base, that we added base to it. OH minus, write that down. Yeah, that means basic. Yes, that's what that means.
Look at you. Context clues.
Context clues, yes. OH minus. All right, so here's the story. How do you get the marks? What's going on? We know what happens because it's called a nucleophilic substitution, which means that one nucleophile is getting out and another one's going in. What's going to happen is The OH minus that starts the story. Because the OH minus is stronger than the chlorine, the OH minus will usurp the chlorine's position, right? And so what you have to show is first the dipole. What's the dipole? What's positive, what's negative?
Carbon's positive. Chlorine's negative.
Carbon's partially positive, carbon's partially negative. The whole idea of mechanisms is you have to understand how charges work. If you have a negative going to another negative, you've done it wrong. If you have a positive going to another positive, you've done it wrong. It's got to be oppositely charged parts, right?
So carbon can be positive.
Not when it's combined with electronegative atoms
You don't.
that are halogens or electronegative. So carbon's going to be partially positive, chlorine's going to be partially negative, and what's attracted to that partially positive carbon? So the 2 electrons on OH minus. It doesn't matter what 2 electrons you pick. Any 2 electrons on OH minus, and you can circle them if you want, that's fine, but it's 2 electrons that make a covalent bond. 2 electrons go and connect to that carbon, yes? However, carbon cannot have 5 bonds. So what happens now? You show that these 2 electrons are leaving with the chlorine. And so now your product is CH3, CH2. You don't have to expand anymore, CH2, OH. And what got kicked out? And that's 2 points. 1 for the correct showing of the arrow with the dipole, and 1 for the final product.
Is it fine if I put CL down here?
The order doesn't matter, as long as you show the chlorine is what's leaving. Hydrogen's not leaving. All right, so this is the shortest mechanism. So then let's go back to why it's called SN2. If I increase the amount of OH minus, why would that make the reaction go faster?
They look stick together.
They're surrounding it, right? So they're more likely to be able to connect. And why does the reaction also increase if I increase the amount of the halogen alkane? There's a more likelihood that these two find each other for an effective collision. So whether I increase the amount of this or I increase the amount of this, both will raise the rate of the reaction. That's why we call it SN2. Be careful with that. So it's SN2 for primary halogen alkane. How many steps is this mechanism?
1, 2, 3.
It's literally 1 step. Because this goes in, that goes out immediately, right? There's no real intermediate except for a split millisecond. This is a 1-step mechanism, we call it. For one tiny fraction of time. So the SN2 is for primary halogen alkane. It's a 1-step mechanism. I always memorized that SN2 was 1 step and SN1 was 2 steps. So it's backwards. The 2 stands for raising the rate of both of these. Will raise the rate of reaction. Raising the rate of only one, raising the amount of one of them affects the reaction. Raising the rate of the other one does nothing. That's where it's going to matter. So, ready to look at the other one? We said we have 2 mechanisms today. What happened? Shook your head. Oh, the line. For the bathroom? All right, let's take a look at this in a paper 2. Give the full name of the mechanism between the reaction between sodium hydroxide and bromoethane. So full name means no letters. Like, if you just write SN1 or SN2, that's not called the full name. What is the full name of this mechanism? It's just called nucleophilic substitution. All right, how is that worth 2 points?
It's 1 for each.
Substitution gets you 1 mark. Nucleophilic gets you 2. Yeah?
Oh.
People like,
Oh, yeah.
do you need one
That's
to get the
what
other?
No, you can get 1 out of 2. Like if you said nucleophilic
We also
addition, you
need to
do 1.
memorize sodium hydroxide.
If I just put nucleophilic, that's it.
What do you mean you have to memorize sodium hydroxide? That's a Prius thing. NaOH
Oh,
equal
it doesn't have to
OH minus.
No.
Wait, what?
They're not asking. No, it's not something separate. It's OH minus. This is OH minus.
Oh.
Again,
I know what it is.
Sodium hydroxide. I thought it was.
Yes.
I got it wrong.
okay. I understand the mistake now. Yes. Go ahead. All right, here we go. So this is a Cambridge question. How will we do it? What do we start with? Do we have to write anything? Dipole first. Partial negative, right? Halogen always negative, the carbon's always going to be the positive. Now, what happens next? Right, 2 electrons on the oxygen, right? Because the arrow starts at the pair of electrons. Then you show that connecting to the carbon, because negatives are attracted to. And then you've got this. All right. Where are the 2 marks? Seek out the 2 marks. That was quick.
I just want water.
Where are the 2 marks? Not a lot of marks here. 1 for dipoles this time,
One for the arrows.
and 1 for the arrows. You got to. Because you got to show that this is going in, and that's going out. You got to show that.
Carbon is always positive. Halogen connected.
Yes, you have to.
Because like the lone pairs, the 2 electrons, the lone pairs.
Not a lot of points. No.
Is that no?
2 points. You're not getting any more than 2 points out of that.
Great.
All right. So
Should be like 7. I was like,
you didn't do 7 things.
I should get 5 for you.
This is worth 4 points for all of this. All right, let's go to SN1. So the first mechanism was SN2. This mechanism was for primary halogen alkanes. So let's talk now about tertiary halogen alkanes. And first of all, let's rewrite out a very simple tertiary halogen alkane. So let's do C, CH3, 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 and bromine. Why not? What's the difference between this and the primary? What's the biggest difference between a tertiary halogen alkane and a primary halogen alkane?
The tertiary.
So this is only connected to 1, right? Whereas this carbon is connected to
3.
3. And so the idea here is that this carbon is accessible. Yeah, it's accessible.
Yeah.
It's only got the two little hydrogens around it. So when OH minus is like, I'm gonna come in and I'm gonna take this place and I'm gonna kick you out, bromine.
Oh, so it's harder to get into
It would be harder to get into the tertiary than it would be to get into the primary.
Because it requires more
So
energy
we'll
to
just-
get rid of the CH3 metal.
Well, they're like crowding it out, right?
Yes.
So they're blocking space.
It will never take the place of, it will always take the place of bromine.
Right. It'll never take the place of a carbon because that's a very strong
I mean,
bond and it's
Would it
non-polar.
take the place of page?
So there's more VR.
Only.
Only VR, nucleophiles only swap with other nucleophiles, which would be halogens in this case. So this OH minus approaches and it's gonna go for it, right?
Yeah.
Whereas this OH minus gets blocked, like trying to go in, and you've got all of these methyls in the way. So far, so good? So the OH minus has to wait until the bromine on the tertiary halogen alkane leaves on its own. And so the mechanism is completely different for a tertiary halogen alkane because the rate of the reaction only depends on the halogen alkane. Because that's what starts the reaction. But David, I'm gonna ask you to move tables. Rate of reaction depends on one reactant only. And so here in this scenario, what happens is this bond actually breaks on its own. This bromine just leaves. Because. I have a reason. Because when this carbocation forms, it's a lot more stable than one from a primary carbocation. You end up with this. But we learned this actually just a few lessons ago, that this right here is a tertiary carbocation, which we know is way more stable than a primary carbocation because it's stabilized by all the carbons that surround it. And so in the, yes. Oh, thank you so much. Appreciate progress reports for first period tomorrow. You'll get them tomorrow. They're whatever they were at noon today in all your classes. So you can check. And so what happens here, why it's called SN1, is because no matter how much of the nucleophile you have, it doesn't matter. If you had a whole ton of OH minus everywhere here, it's blocked, it's blocked, it's blocked, it's blocked, it's blocked. Only changing the amount of the halogen alkane will change the rate of the reaction. Once this slot is open, then the OH minus can go in. Go ahead. Because it leaves, like this bromine leaves. So I'm going to explain a little bit more of how this happens. This is the actual reaction. You'll see. Now, what you're going to notice is this. This reaction is what we call slow. Step 1 is slow. In a deeper study of kinetics, we would call it the rate determining step. So in A level, we would call it the rate determining step, meaning that the reaction progresses at the speed of pretty much of this first step. However long it takes for this to happen, once this happens, the rest of the reaction will happen quickly. So this is a very slow reaction that occurs. And so basically you're waiting, it's kind of like you're at a light, you've got someone in front of you, but they're just sitting on a phone, they're not moving, and you can't go until they go, and then you start honking them, and then until they leave, you're not going anywhere, right? You're waiting for that thing to happen. And so that thing to happen is the leaving group leaves on its own. Now, obviously, this still isn't the most favorable thing, which is why it happens so slowly. But it can happen because this positive charge is stabilized by the neighboring carbons, what we call the inductive effects. And so step 1 is that the leaving group leaves first. Step 2 is that you've actually got right here, you've got that Br minus hanging out, still in the solution, and you've got the OH minus hanging out, right? You've got all of this in the solution. But which one's the better nucleophile? We learned that, or you learned that last class. The OH minus. So again, this shouldn't be coming from the negative charge, it should be coming from the pair of electrons into the carbon, and that makes your substituted product. Don't worry, we will create this from scratch again. This is just shown to you so you have one that's already pre-done. But again, their diagram's not perfect. This curly arrow should be coming from a pair of electrons into the carbon every time. It should be from a pair of electrons.
But the substitution, like you said, is like real estate, right?
Once we get here,
Yeah.
this happens almost immediately. So once that OH minus has the opportunity to swoop in, it does, to stabilize that carbon. That's why you see a single arrow here, because that's going to happen and there's no going back. Whereas this double arrow indicates that you can go back.
Rather than
And
the other keep matching that up.
Right. All right, so let's take a look at this question. This is a Cambridge question. It's worth 5 marks. First of all, name this compound. Look at that. C2H53CBr. What's that? By the way, it's here.
Oh.
Do you see it? Look carefully. Do you see it? C2H5 is the same thing as CH2, CH3. 2 carbons and 5 hydrogens. 3 of them on this carbon, and a bromine. If you pay attention, if you're very savvy, sometimes you'll see the answer to one question is located in another. So drawing out from here, can you figure out what the name of this is?
Pentagon.
How many carbons in a row do you have?
3.
1, 2, 3,
Oh,
4, 5.
Ah.
Well,
Five.
is it spelled?
So it would be
It's pentane.
Pentagon 3.
3 ethyl, pentanol,
3
ethyl.
ethyl. What else? Is
Bromo?
that carbon 3?
Wait, isn't it bromo?
Bromoethyl.
3 ethyl. 3 bromo. How do we write it in our final answer?
3 bromo pentane.
No.
3
3 bromo.
3 ethyl,
3 ethyl.
ethanol.
Pentane is correct
Okay.
answer here.
Pentagon. Where you got the?
Wow.
That's from organic part 1, right? When you name alphabetically your groups. Your longest chain here is 5, pentane. This is 2 carbons long, ethyl. This is Br, so that's bromo. Bromo comes before ethyl alphabetically. That's why.
Oh, so it's not based on what it is, it's just based on.
Alphabet.
So even if it was like 2 bromo and then, no, like 2 ethyl and 3 bromo, 3
It's
bromo.
still bromo. It's B versus E. That's literally how you do it.
So
B
you
versus
could
E.
do bromochloro.
Bromo, then chloro, then iodine.
Right.
Like in that order. All right, so now the mechanism. How many marks is this mechanism? 3. So let's trace the steps. What is step 1 in this mechanism and how do we know? Br leaves. So how do we know that Br leaves first? Why is that the decision? Because it's tissue. This carbon has carbon going that way, a carbon going that way, and a carbon going this way. So because it's tertiary, I like to put 3, this means it's going to be a SN1 mechanism. And what that really means is the leaving group leaves first. Leaving group leaves. So what's leaving here? And we say that it can leave because this is partially positively charged and this is partially negatively charged, and the bromine's like, I can take these electrons. Give them electron. I can handle it. I want those electrons. And so bromine
What are
leaves.
the clear?
Stabilize. CH3, CH2, down to C, CH2, CH3. I'm writing copy paste, right? What do I put on this carbon that wasn't there before? The bromine's gone. What's there now? Positive charge, the carbocation.
Oh, yeah.
Do I have to write the bromine on the side?
Yes.
You actually don't have to. You don't have to, but could you?
Doesn't make sense.
No, you would. You probably don't let it.
You can write it like on the side,
Wait,
some side.
you need to complete.
And the mechanism is SN1, right?
What do you mean to the other side?
Because they're like, just like you said on the previous one, it says antigen. Yeah, like 2 and then, and you're not.
Oh, you could, but they're not giving a mark for that. But you could totally do it. But it's not wrong.
Okay.
So we're right to do that.
That.
They might be impressed and be like, oh, they know their chemistry. Extra points. I don't know about that.
That's how it works.
I thought they were extra credit, you know?
So
You
you
have
get,
extra credit. You should.
But just be more lenient with the next one.
They better be.
you get them in a good mood, right?
Is that your goal? All right, now what?
Leave a box of chocolate with your test.
From this chocolate?
No, for the
You're not gonna
one
say
that
that.
has the grader.
All right, what do we do now?
What do you put the curly arrows again?
To, whenever you're making a new bond, you put the curly arrows, right? So from the 2 electrons to the carbon, And now what? Yeah, you get alcohol out of this. It is alcoholic. Is that a yippee? Is that a yippee? All right, where are the 3 marks? Can we find
Bromo leaving.
all stuff here is 1,
Yeah, the next one.
stuff here is 2, and the final product is 3. So if you're unsure, you can just give the final product, and as long as your final product is correct, 1. But you won't get all 3. All right, number 3. What's the type of mechanism?
SN1?
So they accept it if you say SN1. They accept it, but the mark scheme will say nucleophilic, just nucleophilic substitution.
Use like an extra point. for
Now
spreading.
be careful, because if you say SN1 when it's SN2, or you say it's SN2 when it's actually SN1, they won't give you the point, but if you say nucleophilic substitution every time, you get the point.
So if you were
So-
SN1, it would be correct. right?
What
It would
if
be
I say an SN1 that could be mistaken by an SN2 is
Don't do it. Or
And if they
SN1.
give you the middle step into the 3rd step, would that be nucleophilic addition? Or is that still-
Nucleophilic addition means that you're adding across a double bond. Add addition reactions, right? Addition reaction means that you're adding across a double bond. You're not substituting. So this cannot be an addition. Does that make sense? Because one thing's going in, one thing's going out, this has to be substitution. The nucleophilic addition is actually the final type of mechanism we have to do in a couple weeks from now, when we're in the last part of the unit. All right, so talking about stability, going back to this idea again. Because we did electrophilic addition in the early part of this unit, I usually do it in organic part 1, but it was the one thing that I told you I was moving to organic part 2. The advantage to that is we actually didn't talk about this very long ago. We just talked about this a couple weeks ago. So an SN1 reaction cannot happen with a primary alkane because this is not stable. This is more stable, so it can happen. But a carbon that doesn't have its supporting carbons is not stable. So a carbon that's primary doesn't have the inductive effects, it doesn't have other carbons to help stabilize its positive charge. So this part of the mechanism will never happen. You're not going to form a mechanism that gives a primary carbocation. And so the leaving group will not leave first. In an SN1 reaction, you have to have a tertiary carbocation. So this is the best. This can happen. In a secondary, it can happen, but both types can happen, right? And then in the primary carbocation, it won't happen because it's the least stable. And so the idea being, because in the mechanism, the leaving group leaves first and you've got a carbocation, whenever you have a carbocation, the most stable carbocation is the one that has the R groups that are stabilizing it. R groups are just like carbon chains, sharing the positive charge over a greater area. So that's an important thing to note. So I would just memorize SN1 reactions happen for tertiary, and SN2 happens for primary.
What happens for secondary?
It could be either. That's what I was saying at the beginning,
Oh, yeah.
that I could technically do either. How I have seen it written in a question before, I was telling another class earlier, I've read over 200 unique Cambridge exams. And in all of the, for chemistry, because I don't read the other one, I don't care what the other one. But in all of the ones I've read, the only way that I've heard it mentioned is if they give you a secondary, they'll tell you which mechanism they want you to show.
Oh, okay.
Like they'll be like, show the SN2 or the SN1 mechanism. Yes.
Wait, Amy Central's going home.
Okay, bye.
I was gonna ask, how did, I was gonna ask before you answered, I was gonna ask,
Like, how would they assess that?
How would they assess that? Yeah.
They have to tell you which one they want, basically. So they would say, do the two-step mechanism or do the one-step mechanism. Go ahead. Yes, you may. making sure that. All right, so let's try this checker from the textbook. We're close to done so that we can do some practice and go over your mini assessment, which you'll get next class, I guess. Okay, remember there's a quiz next class.
But it is.
All right, so let's go over this question. What's the display formulas for 2-chloro-2-methyl-butane? 2-chloro-2-methyl-butane.
Hydrolysis.
Now, first one. Draw the structure for
Oh.
2-chloro-2-methyl-butane. Where do we start? Start at the back. Start at the back. How many carbons are in your chain? 4. 1, 2, 3, and 4. Now what?
In carbon 2.
On carbon 2, there's a chlorine, and on carbon 2, there's a nothing. Are we done?
It's bromoate.
Hydrogen,
There is no
hydrogen,
bromo.
hydrogen,
Exactly, chloro.
Hydrogen,
What are you going
hydrogen.
for?
hydrogen,
That's tertiary.
hydrogen, hydrogen. If you miss one hydrogen, will you miss the mark?
Yes.
Oh, I was gonna say,
Like it's hard.
I was gonna say,
Is this primary, secondary, or tertiary?
Tertiary.
Tertiary.
I was gonna say just right.
It's
So you do the 3 with the little.
Just right.
Or, the bottom one, I put CH3, is that fine, or do I have to
You should
write?
expand the hydrogen.
Oh.
If it says displayed, you should display every bond, remember. Good?
Yeah, but I'm not on it.
Are you on AT&T?
I haven't.
Are you on AT&T? Have you
I have
had
six.
service
I
yet?
had Sigma the whole day.
It's fake.
I had Sigma.
I have no sick, well, I don't know, I haven't checked this class
Mrs.
again.
also got it.
But when I woke up this morning, it said SOS,
Yeah,
and it said that all day. Like last time I checked, like, was it noon?
Mrs. also got her back.
Oh, it came back?
I have mine all day too. Mine just appeared.
I'm on the school Wi-Fi, so like,
What is it?
I guess it's okay. But like, I was like, what if an emergency happens while I'm driving home? So hopefully,
I had the whole day.
well, that's nice. I don't know what happened. All right, let's try this one. Show the mechanism for hydrolysis of 2-chloro-2-methylbutane by alkali. You've already known now that it's tertiary. So see if you can try it. This time it's your turn. You do the mechanism and then we'll go to the next question. I'm gonna give you 5 minutes and I'm checking it. So write in this mechanism.
Oh, yeah.
Yep, we're almost done.
So
Then it's practice questions and go over your last mini assessment. Ernesto, put it away. Do the mechanism.
The second one.
Work on the mechanism.
I'm just doing it.
I should check my phone. See if I have a signal. Let's find out. Oh yeah, I do have signal. Okay. It must have just came back.
SN1. No, tertiary.
So see if you can try it. I'm giving you 5 minutes. I'm going to be stamping and checking. So once you have it, raise your hand and let me know. You should expand at least around the carbon of interest. Alkali, remember, is OH minus. How did this methyl turn into a hydrogen? No rush. Did you fix it? Now it's fixed.
What's the name?
All right, when you have it, raise your hand. We've still got about 3 minutes. work out the mechanism.
Can you spell that out?
Thank you.
It works.
What is it? Thank you.
They're both correct. I didn't say what form you
You're
had to
so
do it,
wise.
so as long as it's accurate. And yours?
What?
This counts as two of the five. Because SN2 is technically one, where one goes out, one goes in, the other one straight goes out, and the other one is the leading group leads first, and the nuclear comes in. These are actually two different mechanisms. But they're both called nucleophilic substitution, it's just whether you have a primary halogen alkane or a tertiary. So you learn 4 out of 5 after today. So you've only got one more mechanism to do. The next class, we're gonna do the rest of oxidation. Remember the part that I said with alcohols that I wanted to do that day, but didn't get to? That's on schedule for next class.
I don't clear to this.
Both should be OH, right, on both of these.
Like, this cold, I don't know,
Yep.
it goes through,
Wait, it's 3 steps.
is this also?
It doesn't, this would probably be
Oh, it's really-
warm, but it can be room temperature. We're actually gonna do this reaction, like in class. So it can be this room temperature, which is pretty, I would say not fine. So room temperature is fine. So what you did here is correct. This cold puts the two OHs. The Q2C or 207 would do the same thing that hot came in a forward to, which would be to change the alcohol under ketone. That would be correct. But I'm gonna go over that next class. That's why I said you don't have to do this yet, because I'm doing that next class. And that's correct actually. Checking. All right, I'm gonna go ahead and move forward. Let me get the final checks for your mechanism. Damani, you can show me at the end of class for the mechanism question here. You're missing the chlorine. No, but you gotta show the bond. It's gotta be from the pair. You started from the pair of electrons. At the pair of electrons. All right, I think you have it ready to show me. Yeah. Over here. Where's the pair of electrons? Yeah. All right, one more to check. Yeah. Wait, why are you doing Okay, so I've checked almost everybody, so I'm gonna go ahead and move forward. But it's the two electrons from the bond. Like, how do you disconnect this fluorine and those two electrons from the bond that go? All right, show me again. So we got a couple more to do. So let me get your attention. I'm also going to be going over your quiz from last class. You'll definitely want to pay attention to that. Here we go. Next question. You've got 1 gram of propane, change into propanol. What's the first step in the mechanism? Paper 1 question. First of all, which mechanism are you looking at? What's going on here? One bromo propane.
Oh, we're looking at SN1. No, it would be SN2.
SN2. So this goes in, and that goes out,
Yeah.
right?
Yeah.
Which one of those says that?
D.
Nope. Homolytic says
I don't see the hay thing.
this, that is a free radical. Is that what happens?
Is it A?
It's, you start from the OH minus, it goes to the carbon, which we know is partially positive, and the bromine gets kicked out. So it is A. Good job. That's great. Do you want me to justify any of the others? Or are we good with A? All right, this is a question from last class. I believe it was went over in that lesson. So this talks about precipitation. And there was a test you could use with silver nitrate to see which bonds were stronger than others. And so we said that the CF bond is the strongest, meaning it has the greatest amount of bond energy, which is the reason why chlorine's not getting kicked out. And it goes down to Ci being the
Weakest.
And the other piece of information you need to know here is that the solubility rules tell us, and I'll make sure to put this in your lab in a couple weeks, that Ag with Cl, Ag with Br, and Ag with I are all insoluble. What is another way to understand insoluble? Does not dissolve. And the fancy word we have for that is called? Right? Insoluble means PPT. So what they're telling you here is they had silver nitrate, which is a chemical we are going to use. We'll use it in our next lab, and we're going to use it in our final lab too, that we have to study. It will precipitate chlorine, it'll precipitate with bromine, and it'll precipitate with iodine. The idea is the following. If I have AgNO3, and I have, for example, Ki, this is just an example, what will happen is the AgI would make a solid, and the KNO3 would stay as aqueous. So just an example of what's happening. Here they're not showing you the spectator ions. They're just saying we have silver nitrate, and if silver can find chlorine, bromine, or iodine, is going to precipitate. So then they give you these four random organic compounds, and they ask you which one's going to make a precipitate the fastest. So it means which one has a bond that's going to break the fastest. So which one has the bond? So don't let the two fluorines fool you. This I is leaving fast, and a precipitate will be made because this is the weakest bond. And so the answer here is D.
But why would it not be safe?
Because
CL
the
is on top
CCl bond is actually
So F, CL,
Stronger.
CL, I.
than bromine and iodine. So I mean, the order would be D should precipitate first, then it should be C, then it should be, I would say A and B. And B will precipitate less than A, but this
At the
bond
same
breaks
speed.
at the same speed as that one.
So
So A and B.
it can, how much it precipitates, doesn't matter, just as long as you.
It's saying which one's fast, which one's making a solid the fastest. It didn't say amount of solid. It just said which one makes solid the
So if it was
fastest.
amount of solid, then it would be A, right, the most?
The most solid the fastest, yes. Like if it was that, but doubt that they would ask that. Go ahead, Justin.
What you're saying is that iodine will just go like somewhere else and find like.
So iodine in, yeah, so iodine would disconnect, like leave, if it had to. And it would, if I minus is present in the solution, it gets together with the Ag plus to make this. That's what I'm saying. And the bond breaks the quickest because it's the weakest bond. That's the idea. So this is the weakest bond, it'll break the fastest. This is the strongest bond, it'll not break, basically. Very doubtful the form will break off. Now I do have something to bring up about this exact question. the reason why I wanted to bring up this exact question today and not put it into the class that I wasn't here for. I have studied 200 Cambridge exams, and I have seen this question on 10. Like,
Oh,
word for word, same exact question, same exact responses. There are some questions that I don't know for what reason that they just recycle questions. They're like, hey, this question. They got tired. They're like, we need 40. I'm tired of writing questions. This one looks good. I've seen this on so many old exams. So this is one of those I would just study because there's a shot it shows up on your test, like word for word that question. And I think I've told you all, on average, on a paper one, if you study old paper ones a lot, 2 or 3 questions are recycled on every paper one. So if you study paper ones, you can grab yourself a couple of points just by practicing old questions without even having to think about it. Like, they won't even sometimes change the numbers. I'm like, are you serious? I've seen it happen. Because I'm always looking at the new exams. And as I've studied for a long time, I'm like, oh my gosh, same thing over and over again.
Was it last year?
Yeah, I have it on last year's test. There were 2 or 3 that were recycled.
Well, like this exact one, the one you just showed us.
It was on a couple years ago, yeah.
Hopefully it's on like this.
You never know. But I wanted to explain the why. So there's a reason why the answer is what it is. All right, before going for the day, we're going to be going over your mini assessment. But, a mini assessment too. But before I give it back, we're going to go over the answers together so you can see what they were. So write this down. We've got empty space for organic practice problems. We're going to do number 1. This was the highest scored question, I believe. Most people got this right. What's the answer?
Would it be CH3, CH2, CHBr?
We need to show every
Or
single
no,
one.
CH3, CHBr.
It predicts the product. The question was predict the product.
H3,
Oh, the major or minor?
H3.
CH3, CH2.
CH3,
CH3, CHBr, CH3.
Yeah.
But the
I'll
BR
go in the middle, but it asks for the main one.
Well, yeah, that would be the major product, but you could have it at the end or at the middle.
In free radical substitution, there's no carbocationic.
Ah.
So either of these 2 are the major organic product. Remember in that specific reaction, we said it wasn't a great way to get something specific because you could make so many different products out of it, so many different variations. So here you would have 2 possibilities. Almost everybody got this right. They wrote one of the 2 answers. These are both acceptable. And you only need to give the major organic product, but the byproduct would be,
HBr.
if you give the byproduct, you're not wrong. It's just you didn't have to give it. All right, you should write these down because there's going to be some that you didn't know because nobody got a perfect score. So everybody needs to review these. The second one, CH3, CH. This one was also scored fairly well. CH3, CH, CH, 2 plus Br2. No special conditions needed. What type of reaction is this? I'm just asking predict the major organic product. What's happening here? The only thing you can do is break this bond and add a bromine to the carbon on each side. So the answer here should be CH3, CHBr, CH2Br, right? Something like that.
Yeah.
I didn't specify what format you write your answer in, so you can do skeletal or structural or display. All right, questions 3 and 4 got rough for pretty much everyone. So, question 3. CH3, CH, OH. I'm actually looking at it carefully now. CH2, CH3, plus NaOH. And this is ethanol. Look at your card for elimination of alcohol. Take a look at what the conditions are.
Ethanol.
No. Look for dehydration. What are your conditions for dehydration?
Heat under
Look in your
heat.
card for dehydration of alcohol.
Oh, dehydration of alcohol.
Yeah, what were your conditions?
Yeah.
Al2O3, Al2O3, right? And so this actually was, and I didn't look at it carefully, this is no reaction. Number 3 is no reaction. Because that is for halogen alkane. So number 3 is no reaction. Number 4
Wait,
is this one.
2 is just an addition, right?
Yeah, just an addition. So now you get the halogen alkane plus excess NaOH and ethanol. This is a reaction.
Right.
What happens is you have to take the bromine from one and a hydrogen from the carbon next door. So if you did it right, you got benzene.
Oh, excess. Oh, that's right.
I did do that right.
Excess means happens more than once.
Oh,
So far, so good? Go ahead and write the answers down. I'm going to correct this one because I'm going to give everybody who wrote no reaction this one correct. So I'll be giving these back shortly.
So, next week.
Yes.
Would it also be correct if I did? Would it also be correct if I did this?
I mean, yeah, as long as you keep one in the middle of the space. No, that's wrong.
All right, so I'm giving the answers like I said to all of these. We're going to number 5. You ready? And I'll be giving the assessments back actually next time because I'm going to correct everybody who had number 3 is no reaction. I'm going to give everybody that right. Continue. We're good to the next one?
Yes.
David, are we good? Or you need a little bit more time?
No, good.
All right, let's go to 5. So, number 5. This was given the following monomer. Give the repeating unit of the polymer. So, given the following monomer, give the repeating unit. So, this was 5. Some people got this right, but not everybody. I tried to write it in the format it was intended to be written in. So what would be the repeating unit for this polymer? I mean, this is the monomer. We want the repeating unit for the polymer. That's question 5. You would do C, single bond C, H, OH, CH2, CH3, H, this,
Oh,
this, and what's the other part?
The end.
The little n. That was number 5.
Number 6, 7, and then there's like 8 or
Oh,
7.
that's ours.
Okay, go.
All right, ready for the next one? Six. This one said to give the conditions, but even if you gave the correct product, because I forgot to fill in the product, I gave the mark to anybody who gave that product. So what's the conditions for number 6?
UV light.
Nope. Not free radical. Nope. This is an addition of hydrogen.
Oh, so
There's one of 2 metals you can use, either
Oh,
nickel
platinum
or platinum. So that would be the correct answer here for number 6.
It would be
All right, 7. This is given the reactants and the products. What is the condition? Told you to go to that card, right? What are the conditions? This was probably one of the poorer scored questions. It was Al2O3 keeps No, you can just say heat.
Heat and what?
If you had just written AL2O3, I would have given it. Because that was specific for this reaction. Humans.
Oh.
The
I know what it
little.
is, I don't know what it means.
I got at least 2 wrong.
Alright, finally, 8 through 10. The mechanism
Oh my arrows.
was scored very poorly. I didn't expect it to be so poorly. H2O gas to propene, but I'm going to tell you where it went wrong. Start with your propene, right? C, H, 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 C, H, C, H, H, right? Propene. Almost everybody wrote water wrong. You can see where you went wrong with it. Water is this. That's water. That's water. Where it went wrong is many of you wrote water is this. Now, although that's how water breaks apart, when it's placed in an aqueous solution, the actual molecule water is this. It's the Lewis structure of water. That's where most people went wrong. I'm just throwing it out there. I didn't realize that would be such an issue, but I learned now. So that's why I'm teaching you what to do with water. So, what's the thing that we do to do this mechanism? This is the same mechanism from the boat work. You first need the dipoles. On water, one of the hydrogens you put a positive charge, the oxygen you put a negative charge, like that. And the other hydrogen, if you wanted to, would also have a positive charge. But you technically don't have to do that. Now, where does it start? This bond breaks, grabs this hydrogen. Then this bond breaks and goes to the O, right? Which is why you're going to end up with OH minus on it eventually. So then you end up with your carbocation, which would be the carbon in the middle, and like this.
Oh, then you add OH to that carbon.
Then this gets added into that, and that gives you your final product.
Oh,
I don't know if anybody got the full marks on this, and I think it was because of what happened here at the beginning. Some people got close to full marks. Alright, so I have your homework, and then I'm gonna make a couple of, I said I was gonna fix question 3 for everybody, and then I'll give you back your quizzes. But let me give you your homework first, so you have that. This homework is due Sunday night. There's also tutoring today and on Tuesday. Today and on Tuesday.
This is for Monday, right?
This is due for Sunday night. Always the night before next class for the most part. This is for today's lesson. This is for today's lesson. This is for today's lesson. Here you go. Not right now. Hold on. Give it to me next class. Or hold on to it till the end of class, don't put it away yet. Let me fix something first. Did you say you made a lot of the mistakes?
say, I didn't hear you right.
All right, in the future, if you leave a question blank, that doesn't count as no reaction. Make sure you write no reaction if it's no reaction. Don't leave it blank. Did you say 25? All right, so I got your mini assessments to get back to you. Ernesto, did you keep it up? All right, so I'm giving these back. I staple them together. All right, starting with Diane.
Oh, that makes sense. This was for
Ernesto.
Because they were.
Ben. Ben. Sophia.
Good afternoon, Cold Nine. This is Emily.
Attention CIE students, wear the appropriate student. Your outfit must be installed colors red, black, or white only. Our shirts are worn only on Friday. School clothes should be worn Monday to Thursday. PE uniforms can be purchased online at IT.com or at the end of the location. Your student ID badge or identity. Drive the school. 7:10 to 7:15 for the party. Classes begin at 7:20. Progressive discipline is in effect for student party violations.
So use this knowledge to help you study more for the next one.
Outside or under the covered area. LP in the hallways, that's what's going for you. Bring it back to school.
Yes,
Today, it will be done in the this afternoon. There's about 10 students that will be scheduled or have their detention today. Not here. You're ready to get it.
All right, remember the top 6 scores are the ones that are kept, so you gotta study. Top 6 scores are kept. Why?
I really need a mix of credits. So you have, so you have.
I wrote in on the wrong thing.
Their reports are OTC scholarship included.
No more negative, and we should be on the schedule for until spring break. Coming to tutoring, yes.
The afternoon announcement for the rest of the ACI.
Oh, I got my stuff here.
Yeah, I got so confused.
Yeah, I wrote the H2O.
I didn't realize that would be as confusing as.
I wrote the exact same thing he did up there.
That's why I'm.
As soon as I saw the mechanism, I'm like, oh, I remember this. I saw H2O, I'm like, wait.
Same.
What?
You can't break the bond because they're non-polar.
Oh, because the bonds are not.
It won't react because it's non-polar.
Hey.
You could just say alkanes are unreactive.
Okay, yeah.
Yeah.
I'll let you know if you just stay in the building, you could.
Okay.
I've already got. Well,
Remember the top 6 scores get kept. So there's only been 2 you've taken so far.
I will give you $2.
You can drop 3. Just for this one, you take these two bonds.
Oh, wait, this is Vincent's charger.
Like, you take those two
Keep it
bonds.
safe one.
So, do you see how I did that? Like, these two bonds go away. And then you've got this, but now you gotta make this a double bond. This one have Samani, give it back. It goes back to
Next
the
time we gotta do this.
my charger.
Yeah, that's fine.
Oh, this water.
I studied very hard at the beginning of the course so that I can read that. Not only that, really, but my only that sense is like the anxiety was less, and if I could tell myself I only need a 40. I would still do well, but I would be like, I only need a 40. Whereas if I'm at the point where I'm like, I need a 90 to get an A in the class, I start stressing and it's bad. Yeah, that's how I became so good at like calculating, I guess, like grade point. Like, what is like? Why are you doing? Why?
Now, you need to be more creative.
Oh,
man.
it's the same thing?
Yeah,
Ronnie, give me back my cable. He has the cable.
David, not recipe. David, that's a fact.
Give me back my cable.
Why? Tomfoolery.
Tomfoolery, there you go.
Tomfoolery.
I love how Julio just left his phone, his work.
He'll be back.
I know, but like.
Apparently cell service is back.
Yeah,
Is that his charger too?
yeah.
We should probably put it in the table just so we see.
Solar flares.
Huh?
Oh, no, somebody was just telling me it's not solar flares. There's a dispute at what's causing it. People don't know, like, what happened. So I guess different people are saying different things. All right, don't forget there's a quiz next class. Next mini assessment is next class.
Oh, what? My what, love?
Time to
You wanna
go.
say David, why? That's why I don't like sitting with you, so mean.
What in the world? Y'all gotta go so I can go. I can use the restroom.
David, what did
Well,
you do, bro?
I put the little puzzle for you, but I think. No, it's the other one.
I'm never gonna leave. I'm never gonna go use the restroom because of your tomfoolery.
I'm telling you, like.
Yes, that's not the restroom because you're not, huh?
Because of your tomfoolery.
I put in the effort.
I don't get a break all day.
I put in the effort just so you have a little more fun.
Bye. Go out the back door, please.
Okay. Bye.
Bye. Have a good day.
You too.
All right. Like I said, I'll be right back. See you tomorrow. they had tutoring today, so when you're on today, so like, come on in, how's spring?
There would have been.
There, oh yeah, there will be. There's still a couple.
Guys, sit here.
Yeah, let me just give a sheet for everyone to sign in. You're here today. Hi. It is on Monday. This is for ACE tutoring.
Oh.
Today is ACE tutoring.
That's awesome.
Sarah just needs to make up her thing. Right? All right. So Julio, Damani, please sign in. Also, Isaac and Sammy that are working on homework, go ahead and sign in as well. Sarah, sign in that you're here. I just put a star next to your name if you're taking a test.
Oh, okay.
Yeah, you signed too. My phone finally came back. Like I didn't have internet all day. That's crazy. Or not internet, but like cell phone service. That's crazy. It didn't matter while I was here, but like I was worried about like driving.
Oh, yeah. They cut
And
that.
didn't see-
Like if you've got nothing and what an emergency happens and you're on the way
Because this
home,
happened
you don't have
that
any
same
signal.
thing.
Yeah, I came back like in like.
When I was driving this morning, I was like, that's not great. I wanted to order my coffee, and I had to go inside and talk to people. That's hard.
Man, that's tough.
I want to talk to people in the morning at 6.
Me neither. That's great.
Talking is hard in the morning.
Yeah, it is.
Where am I gonna grab? Yes, today.
What more am I
Like, what, you
gonna
have your coffee?
start?
I didn't even have my coffee. I had to say
Yeah,
words.
the same thing.
They know my order. though.
Hungry.
Oh, they do? So
Yeah.
you're calling it over?
When I came in, I told them I couldn't like the order, like I couldn't do it in the app. And they were like, okay, I got you. All right, you working on homework today?
Yeah.
You want me to work, don't you? Did you do the oxidation homework?
I did all of it. I did all of it.
The one I was given with the egg puzzle? No,
I just didn't remember.
the one that's due tonight? That's the one that's due on Sunday.
Yeah.
Are you gonna do this one first because we just learned that?
Yeah.
All right, that sounds like a plan. That sounds like a strategy. All right, Sarah, let me give you your test back.
Yeah.
Oh, no, not this. I'm gonna close the door.
Yeah, just,
Come
yeah.
here. That's annoying.
You do it then live?
I'm so glad we haven't really had too many interruptions to our class period.
Yeah.
Second period got hit pretty brutally one day with it, and this is class third period.
Oh, yeah.
There was one day that
You couldn't.
we couldn't hear each other. We actually all went to the back to like work. Remember the day that it was so loud?
half for you?
Huh?
Is this half for you? He says, do you want half?
Sarah, here you go.
That's not how.
Here you go. At least they waited till after school. This is bad. Alright. You can do that.
Oh, yeah.
I am with the.
You can do this.
I feel like literally was.
Either work on your homework or got it up. They're going to the back to get away from the sound, probably. Yeah, escaping. That's good. Yeah, that's good.
Yeah.
You replace the hydrogen with either.
What's this plate again? With all the height? There's one of those basements.
Then create space. Write it on paper. I was saying in your class period, one time the room sound was so bad, we all had to go to the back of the room to like work on whatever it was we were working on. Remember?
Yes.
It was third and fifth period that day. It was just brutal. It was a while ago. It was like
I forgot my work.
you forgot your work.
Because
Did you do this or did you?
Okay, I have separate days. I put up separate days. I put like 8 days here, 3 days, 8 days.
You got coffee?
Copy?
Yes.
Conversations.
Yeah.
Yes.
Like I print out extra copies typically for those wonderful students that forget or didn't come to school or whatever. Here you go.
Propane is good, right?
Yeah, I always print out extras.
4. Number 3.
Wait, miss, why do you have to use the king height rating?
Metric to metric, so like milliliters to centimeters. So if you
Oh.
see the units matching the back of meters per liter.
Really? Why are you looking at my thing? You wanna see how
And then
many?
it should use
And then this one I have to use this.
or you may have to use a combination of the two. It's on one question.
Wait.
Like for example, you can do inches to centimeters, and then centimeters to millimeters.
Oh.
You see what I'm saying?
Inches is the matching one?
Inches is English,
Oh.
meters is metric.
That was 7, what happened?
So you could go inches to centimeters on that chart. To go from centimeters to millimeters, you know that's smaller.
Oh. Okay, so, wait, so whenever it's English and then magic, you have to go. Then when it's magic, is
No,
magic,
you have
it's
to
the
4, 2, 5, not 4 and 5.
Then,
And then if it's English to
Like
English,
the-
it's
It is 4, 2, 5, or
Yes.
How many is content?
I don't know why it's separated. I don't know why it's separated. It's
No,
just
I
like,
think 7,
imagine.
If you guys have time to finish your homework, we can do more practice questions. So you can master.
I didn't know this one.
Oh, the benzene.
Yeah, I was confused, but it said ethanol,
I was having a good time. Like drawing them out.
and this one either. And this,
Yeah, you can
this,
study the
and
dehydration.
this was all the same.
Study the dehydration.
This and this were the same, so I just put ethanol.
Because that was from the lesson.
Yeah, but this was wrong.
Oh,
This is
yeah,
what
yeah.
you found out, it just, why this is wrong. I tried cheating.
And it
And
failed.
yeah, and it backfired.
Because this should have actually been
Yeah.
AL203. Because the answer was not here, it was AL203. Whoopsie. Life is hard. I still gave you one of them, because I gave you this even though, like, it technically shouldn't do that. With the NaOH, it should do this with the AL203, but I went ahead and gave it to you. Like, if I give you a marker, I have to take it away. But it should be no reaction, actually. Which might be So, yeah, I think this messed a lot of people up.
I was confused because there was 2 hydrogens in there.
No, but you're supposed to display it.
Yeah.
Yeah, find that out.
And then the OH minus will
We
get
are
added.
zero.
It's okay. You can drop 3, right?
Yeah.
So we're hurtling towards the ones you can't drop.
I got 2.
Oh, that you can drop?
How many Teslas are left?
There's 9 altogether, so
2 seconds, 2 seconds.
7 mini sessions. Next week, there's gonna be 2.
That's not here.
Monday and Wednesday.
Yeah, these two can be right.
Yes. Yes. It's that thing. That thing.
Oh, no.
7, right?
What's a pentagon? Do you know what a pentagon is?
I don't know shapes.
It's a house. We'll make a house. How many sides does a house have?
6.
No.
What house do you live in?
5.
Your house goes like
Oh, wait, no.
That's an interesting house.
barely started.
Yeah, because it makes look at you.
Everyone knows pens. Everyone knows a pentagon.
The first page is like mainly create stuff. Like a good review. You remember create, right? Because you guys definitely did organic at your school. You literally learned that in like October, right? It's a beginning thing. It's literally unit 2. Do you never do those? That's rough. I wonder whatever happened if that didn't.
I think you started with someone close to
I think she got out of high school. She was not happy working with teenagers. It's not for everybody. Bye. See you tomorrow.
See you tomorrow.
There you go.
They're gonna learn moles tomorrow. And create, yeah. They're learning moles tomorrow. I bought something for them for Monday, Tuesday. I think I'm gonna do it. I bought black cardstock and chalk. Chalk is actually calcium carbonate, So I'm gonna have them like draw with chalk on the cardstock and then count the amount, like put it on a scale and go find the amount of atoms of calcium, carbon, and oxygen that they drew on their cardstock. So I'm gonna do one. Sounds like fun. Because I bought scales that are better. They do 2 decimal places instead of 1, so they're more sensitive this year. I had to buy them for last year's basic exam.
What's wrong, right?
$600 in scales.
It usually is, I'm not gonna lie to you when it comes to this, but I got an entire half of the test that we had with displayed instructions, I got stuff. I put displayed instructional, specialist displayed.
That's bad. You don't want to lose those points.
Fair, honestly, never even thought about that.
Let's say it in the word.
I just assumed it was like 50-50 and I just got it. It's not right. It's not right.
Yeah, it's good.
Yay.
Except this is not structural formula for 3
Oh, I got it. Whoops.
CH3, CH2,
But you did it
CH2.
twice? Yeah, I did it. I did do it twice.
If you guys want me to check your answers, I did work out the questions earlier, the homework questions.
Can you help us with?
Sure.
No, you're wrong on everything.
And any help
Which
with
one? This one? Are you done? Yeah, it's right.
Yeah.
So since this is,
No.
and then
Tertiary.
use this.
Not yet though.
Here.
We first have to change issues too.
So I'm curious.
So you set up your conversion right to one.
So I don't know how I'm supposed to after.
Get the answer. Oh, this is it. This is centimeters. Now, if you want to go from centimeters to millimeters, you have to
So,
set
right.
up your strategy. The king Henry died until you memorize.
Fuck you.
King.
It's 6. See, I got it. Yes, I did.
You said.
It's 5. That's what I said. You're hearing things.
You're going from the little m to the little. That means you're moving your decimal. Sorry, you're going from the little c to the little f.
Wait,
C to the f.
no,
You're moving
I
your
wouldn't.
one
I probably would.
Oh, that's what I have to do.
That's needs to do.
Wait.
No, I probably still wouldn't, because I wrote them.
So once you are in the metric system,
You just have to move it
you just have to move
like.
your decimal to the left or right. So it's expired.
And then
So
he
this is
said,
centimeters,
no, I
but
couldn't.
they're asking for
I
millimeters.
could hear it.
You have to move one over.
Like it, you.
Oh, this is
Like,
the.
it'd be so traumatizing,
Yeah.
and that in that same moment,
That's millimeters.
I would instantly forget what he said.
You move the decimal down.
He'd like in and out, just not.
Yeah.
What was that?
Wait, how many do you have to make it to? 2? So it'd be 4 or 7. Without 4.
If you were there, and that was happening.
Oh.
If that happens, like,
Yeah.
you guys can take me.
I can tell anyone that happens.
All right, back over here with organic chemistry. My love-hate relationship with organic. It's a lot of memorization is the thing about organic chemistry. That's the hard thing, because you gotta not get confused in which thing you gotta do. What this means.
It's a nucleophilic substitution, right?
Yeah, it's asking why is it a substitution, so like,
It's a replacement, right?
because OH minus go in, Br get out. Like, there's a replacement that occurs between bromine and OH. That is from like a revision, like a Cambridge revision. But you can tell that that's not like an exam question. Why is this a substitution? One in, one out. You know, you can tell if you have a Cambridge question by the type of writing, right? Like the way that the font is like, that's a Cambridge question. And also when you see the little one with the little brackets around it, that's an indicator.
You should let me think. What do you think? Because I think it's because it has lungs, right?
That's right. We said that in the beginning. And it's also in
Yeah.
that you totally watched last night?
I did. No, I did. I even have the notes.
I literally went and messaged every single person on Tuesday night. I was like, you didn't watch it yet. You didn't watch it yet.
I know.
I did it yesterday. I was tired, but I did it.
It's hard. But this is not too hard of a week. You didn't have any mini assessments this week.
Could be worse, could be worse. 2 more F's in the grade book, and to do that.
For what?
For the minutes.
I'm not putting them in the grade book until they're all done.
Was it like an average of all
I'm
the
putting an average of the top 6.
Oh.
So your lowest 3 just automatically get dropped.
So
But after 3, you don't have like any more buffer. You have to, so some people I overheard say, I gotta start studying now.
You still have buffer?
You gotta start studying. So why would you save your buffer for the end when there's more?
Save it, it's gonna get harder. So if you save it for the last 2, just not do them.
Take your average earlier and be
Exactly.
okay with that?
I just average it when I got it.
It's okay, I don't wanna do the one on mechanisms.
Just try it how you can.
So this was
That's the
silver.
silver.
So you would add silver nitrate, and if you see a precipitate, this would tell you you have bromine, right? Bromine ions. Add silver nitrate. And if there's a precipitate, you have bromine ions. That's good enough for now. I have more to teach with that, but that's good enough for now. But it's better for me to teach it by showing you in the lab. So you'll get that with the lab. So you just have to know what means it persists.
Oh, no, the last one's not it. 1 and 2. Because that has to be NH2.
Becca, you're not from today? You said it turns into NH2 and then it became like H10.
Oh.
Remember, I wrote it as
Right.
the objective slide? It was also in here.
3,000?
The little
3,000?
mistakes become big mistakes.
3,000.
Right here.
Do like exercise so you get one more.
And then the H goes with the PR. No.
So
Yeah.
follow.
Are you done?
What's the question?
Would you like to stay to work on your homework or?
Yeah.
And you can get the credit then for the 5%.
Yeah, okay. And, oh yeah, from the 5% of the last tutoring or this tutoring?
No, this unit. If you do it now, like you already, whatever your score is, I'm gonna add 10%. Oh, because you get the 5% for tutoring and you get the 5% for the packet.
Oh, okay.
So when your score goes in, it's always I add the 10.
Okay.
Or whatever the number was for that one. For this one for you instead.
Tell me. You tell me.
Probably the weekend.
Answer the last
Was
one.
it Thursday
I
already?
didn't say the answer to
Probably
the
the
teacher.
weekend, sorry.
Okay.
Because I gotta go home and make a lesson for tomorrow. As teachers, we go home and we just work more.
On table, I'm 120% sure.
500?
Because you put
You're not thinking probably.
I think if you got trust me, but it's usually
I know the probability is fine. You did? Well, and trust you rescue.
you stay with state matter.
How do you say it?
Miss, did you hear what he said?
Why did I hear state of matter?
Yeah, he said, did you say what state of matter was?
Just kidding,
Oh,
I was playing around,
it's
but
not-
he didn't know
the
the
answer. I just think this is the exact same.
Your
question,
units!
like a Puzzle.
You need your units. Get on them about those units.
See someone who didn't play
Make those units cancel. We're going over canceling units today.
Como vai ser repetido?
Miss, I'm almost at 200K points.
D.
You're doing really well.
I need to get,
You have 43 to go. It's not that much.
C.
yeah, and then I need to
You
get.
will either get it by the end of this unit or like at the beginning of next unit.
Is it like 8 units in total?
There's 8 units in total because I'm breaking the math into 2.
Oh.
I'm gonna break it probably in such a way where we finish right before spring break. Like wherever we're at there, that's gonna split part 1 and part 2 of the math.
Yeah.
Because I don't wanna give you a test right after spring break. That's not fun.
Yeah, that's not fun.
So like I'd rather give it the week before. But I'm assuming your other teachers will probably do the same.
After I get 200K points, I just need 50 more.
You're given a choice.
I would just get it out of the way.
Everybody voted for the later date.
I voted for the day.
What was it, the 21st versus the 19th?
Because
Yeah?
I'm not gonna be here on that day.
Oh, so you're gonna have to wait a week to take it if you don't take it early.
Your
That's
fault.
rough.
No.
Because then you have to study it a week
There's
later.
everyone.
But I'm blaming you.
It's gonna sit over your head.
Someone's gotta take the blame.
Now you have a
Blaming
test,
you
big
and
test dangling over your head.
You
You could take it early.
Oh, yeah.
What?
Imagine.
A day before.
Exactly.
You could take it the Tuesday before after school,
I'm not gonna be
like
ready.
during tutoring. It's possible, you just gotta let me know. I'll do it. You don't wanna do it?
No.
But then you would get it off of your basket, and then you could relax spring break.
Earlier, you had the last day.
You went on to new material.
Exactly.
But it would be light work because it would be the beginning of the next unit.
Instead of a test.
I can take the test and then go off with this spring break and.
And not have to learn
I'm
something
so glad
new.
that the last thing I'm gonna do in school is a hard test. It's gonna be worth part of my grade.
That's the best part. No, it isn't. That's the worst part.
So you go into spring break kind of knowing where you stand.
Nervous, because I
So
gotta wait
that
till we finish
now you
grading
know
it.
how much you have to study for the quarterly.
I don't check the grade.
I'm gonna be right the day before school comes back.
That is the wisest thing to do.
I'm gonna be checking every day till it's in.
Actually, as a teacher, sometimes I wait. I'd rather wait, if it's a break, like, I probably will wait till the end of spring break because I don't want it to sit over your head.
Anxious. All thing. I'm gonna think I failed.
Go enjoy your time, and then when it
Tired
comes back
time.
on Sunday.
Then you let reality hit you.
I grew up
And then
with
you
it.
still have a quarterly exam though,
Yeah,
like.
but
when we
that'll
do
only
that.
replace one of the.
It'll replace
lowest
one of your
grades.
lowest grades,
I
so
did
that'll
do well
either
on the
be
first one.
the empathy test, it'll be these mini assessments, or it'll be
Did
your
you do good on
unit
the
test.
empathy test?
No, fees. Yep, fees goes.
You did
I
pretty well, like it was
God.
high C though, like it was close to a B. That was actually one of your higher scores
Can't make a B to God.
on the unit test.
It is sullying my A's and B's. Sullying.
Quarter three is tough. I tell everybody that at the beginning of the year, like in Greece as well, like quarter three is just rough.
Yeah, let me test it. I'm gonna test, I would skip them.
You actually did the math. And look, it helped. You missed some classes if I recall.
Yeah, I missed like 2
You were
classes.
sick.
He was.
I was ill. I had the flu. I didn't want to spread it. I'm a good
I
friend.
get that.
Wear a mask.
That was the reason I didn't come to school the one day, because I didn't want to spread it. Like, I don't want to be that person. Actually, I had a fever though. Like, I had an active fever too. I was debating. I was like, if I could Zoom in, would a sun set me up and I could teach your class from home? I was like debating it. I have the technology to do it. Like, it could have been done.
You have to set it up.
You just gotta project me. I'll write it on the screen. I used to teach like that.
Screen share.
Yeah, because of COVID.
Yeah, I used to teach like that. Like, it's possible. It's just that I didn't have like this printouts. I would have had to drive the printouts to school, like for you guys to follow.
Yeah, facts.
Faxes and stuff.
I'm actually pretty sure I became dumber during COVID. I
Likely for
forgot
many
stuff.
people.
No, because like the urge when I'm sitting at my table, and then I go to
I could
sleep,
be playing video
And then
games.
just like-
I could be on my
I
phone.
could get like an hour of sleep right
I would
now.
say 70% of students are either sleeping or playing video games.
Yeah, just so many options.
And that was at CIE. I
I
can't
was-
imagine what QE. Actually, I can because I taught there when COVID first started. It was out of the 150 students I had, 10 of them came to class because they allowed you that year
Yeah, they
to
did.
not log in. Like, and they gave everybody whatever grade you had before COVID, you just could keep that grade. So if you had an A before the end of fourth quarter, they were like, God.
Same grade anyway.
Except my ACE class. Every single student in my ACE class showed up every
They
single day.
cared.
Because they cared.
They cared.
Like we were like in it. We were in it. And they came and they learned and we tried. And those kids, like, because we still had an exam, it just was different because they didn't do it over Zoom or whatever. But they still tried and most of them passed. So,
It was until in the next
but
year.
the other kids, like regular and honors,
later in the year, for my school, later in the year, they allowed you to go back to school with a mask on. I took that off because
Had to go. My parents wouldn't let me stay home.
I had some students that were forced to go, and I had some students that wanted to come back because on their own, they knew that that was the only way that they could learn.
learning online was hard.
I didn't learn even.
And
when I was
even
there.
then, teaching when half the students were in front of you and half the students were at home was not fun.
It's like you have to go back.
You had to go back and
You
forth.
would see the teachers, I gotta go to the computer to
And then you check your phone later, you can see that all the kids are sleeping, and then there's the kids with the skull.
They would have their cameras on. Or some people even, they would like,
Fans, you just saw fans, like they. turn the
Turning it
camera
off,
to-
you
yeah.
can see a roof.
or some of them like would have a picture of themselves, like looking like they're sitting there and they're not.
I did that. I'm not gonna lie. Like when you teachers teaching, or like looking at the board, I'm sure they won't notice when they go to sleep. Come back. Everyone was gone but me.
Oh.
That's how they, they should probably wait and
Yeah.
watch it.
One letter is the late sooner.
I'm gonna time.
Yeah, she definitely.
I have to make it to that.
That's Spanish.
You are a Spanish speaker, it's not that hard.
Exactly. I could just do this stuff online.
And then you stop there to your next. Once
And we have
you're next, and you do the answer to that.
Yes, I got it.
Oh, so put equals, like put equals.
I would go in person and sometimes I wouldn't go in
And then
person.
multiply the two numbers. Oh, yeah.
So every time we did a test in biology, guess who wasn't at school?
Someone, does this go with
Yeah.
remember the test?
Still pretty fast. Anyway, aqueous silver nitrate solution is added separate to containing
Yeah, I got 8.
fluoroethane and bromoethane. And iodine is there.
Just point 0
The
counts.
top of it, substitute are heated
There is-
in a warm bath.
Oh, okay. Now they want.
And then a yellow precipitate appeared, first in two containing iodine, followed by a green precipitate
Wait, well, how does this four get erased?
in two containing.
Oh,
And
yeah.
finally, a white
You just
precipitate
write it.
appearing in two containing chloroethane. Ethane.
Like that's what it literally means. Throw it out.
Okay.
In two.
Throw it out. Alright, how are you?
Confused on the observations of why silver nitrate has different colors for each of the halogens.
Was that in the notes from last class? If it's not, you can skip it.
Oh.
Try to say questions up.
Oh,
I'll write that on the Google Classroom up here. That is the advantage of coming to your, you can figure out.
No, it's actually kind of slow stuff. You're good.
That would be the
Oh.
start reading here. You're reacting with an NaOH. They're asking for you to show the mechanism.
Oh, I see that.
Yeah, it repeats.
Some man or some person along in the world made all of these words to describe all of this. Because it made sense. What we did.
Well, if you come over here, I go.
And created.
Somebody just made up a word,
Made it up.
It's not all words. Oh my God.
and everybody agreed that that's a word.
I mean, we could communicate it if someone disagreed. No. Like if everyone was like, no, and that meant yes.
Oh,
Then you'd be French.
look, you see what's C? C,
Oh, it has to be
It's confusing.
the joke
To,
one would be French. To S. Or you have to
C
say
to
one.
F. Yeah, so one right.
What is it?
It's a mechanism.
reverse.
You're
Oh, it
doing
turns
from
into this.
chlorine to
Okay.
OH. Is that a primary, secondary, or tertiary halogen?
Secondary,
Is it? The carbon with the chlorine on it?
primary,
It's
primary.
primary, so it's gonna be a SN2. So you have to add the OH minus because they're not showing it, so you have the OH minus.
Wow.
And here's-
How do you do the opposite of this?
and then you show what happens.
You have to make it either to ascend.
Yeah, I was.
Not an odd number.
I was trying to count.
Give me three radicals.
And,
There, yep.
this one,
Arrow ends here, and then you have to put partial positive on carbon. Partial negative on the
and then
chlorine.
you would like circle these two and.
Mm-hmm. And then something else has to leave though.
Oh, I make them just.
Like, it
Oh.
doesn't make 5
Oh,
bonds
yeah,
forever.
that's-
Yeah.
Bonds are fun.
Yeah.
Is
For
that
a
it?
millisecond. That's it. Only 2 marks.
Oh, those, right. The arrows in them. Okay, write a complete mechanism for the reaction 2-ion, 2-methylpropane.
Look, you're almost done. That's the last question. It's a mechanism. We did one, like this, in class.
Propane is very good.
The decimal to the right way.
That's right.
So it's fine.
No,
It's right way.
Yeah.
Were you reading that right?
No.
it's iodine.
It's,
Yeah, that's twice.
and,
You're missing hydrogens. Can't take it. You could just write CH3. Exactly. Do you have to write that spectator and should you?
No, it'll.
You should not really confuse you. Write a which minus.
It's 3 times.
Confuse people meaning confuse you.
3 times.
Like if you write the whole NaOH, you're just gonna confuse yourself. So you need the OH minus, right? Plus OH minus somewhere.
Wait, so,
And then you need to show like this leaving first. Because it's a SN1, so in the SN1
So
reaction, this leaves first. Oh, which is what you've done. You've
Right.
done that, but you gotta show like a little arrow with it just leaving. Like goodbye, like in this one right here.
Yeah.
So
Take out the numbers,
Yeah.
so that doesn't
and
confuse
then
you.
you
Oh, no,
put
this
the
doesn't
carbon,
have
the
any.
partial positive, and the
No,
negative.
this person
Negative.
has intermediate step.
Partial positive,
Which one's the one with the intermediate step?
that does have an intermediate step.
You moved the decimal to the right.
Donnie has the intermediate step.
But if it has, but if it,
The iodine leaves on its own.
Add 2 minus 0.
It's SN1 because it makes the carbocation. And then when it makes the carbocation, now the OH minus will go in, so you can rewrite it again here.
That's what you said.
That's what you were gonna do.
No, I'm stupid.
You're not stupid. Nobody in this class is stupid. You all just need to study. Nobody is stupid. I will tolerate it. There to the basically to the carbon, the positive charge. There you go. And then that's the bond that gets made, and then you just have to write the final product, which is with the OH on it. Yeah. Mm-hmm.
Yes, it's 10,000, right?
So where's your OH minus that you gotta add it?
Yeah, that's OH.
It was a bad mistake.
With the electrons.
This is a full mechanism, yeah.
Can you imagine just leaving your head in the test with the electrons?
There you
I'm
go.
not gonna be there because they're testing on you. Yeah. Just gotta take pictures and do the other homework now. The one on oxidation, look at how much you can get done. You've got time to do the other one. I can. But what about your homework, the one that's due tonight? What? How do you not have it with
I
you?
was gonna do it, I was doing, the Excel book for yesterday, and
I thought I had it, but this is my other book bag, and I said I was gonna do it yesterday. I was doing it in school yesterday, and I didn't.
Uh-huh.
there you go. You see yours.
Well, at least you've got this one done. Sure. And then I'll come back.
Bro, what?
I can guarantee that's not true. Okay, let me see that happen. Feeling a little nervous.
It's supposed to mean
Oh, but there's multiple.
I mean, you can make it do it this way. Oh, yeah, do the thing.
I'm getting my own calculator. Can't take it. Too much effort. I'm not putting that much effort.
Oh, like the video from that one.
I'm so picky about my calculators.
Mesa always says that even more.
Yeah, I got a different answer.
But then,
How did you get 150.48 from 12 times 2.54? I think that might be the issue.
So I think just randomly there.
Oh, did you finish
Well, I
it?
got
For-
all. I got 30.58.
Yeah,
Yeah, it's due today.
I don't know how you got that number. It's like I have the same ending, but it's something completely different.
The one for
I don't know what you
Cambridge.
did.
It's supposed to give me 30.58.
day. Versus at 10,000.
Divide by 30.48.
Okay, then.
That's a correct answer.
Okay, it was calculation.
I definitely get it.
So
Maybe
don't
we
circle
looked at it,
six
I'm
is
looking on
6.5
it.
anymore.
No, it's I think four.
Gotta change it,
It's I
right?
think 4 Cambridge.
Yeah. Wait, miss, with this I can see how many
Wow.
kilometers
I
are
was gonna say, but I
a
think
mile.
my mom's calling me.
1.61? It's not on there?
Hello?
I don't know.
Okay, done.
It should be on the paper I gave you.
The mass.
Yeah, you're gonna have to-
value.
No, but I gave you a
Do all
full paper
this.
that has more.
Hello.
Oh, yeah.
Kilometers to miles, I'm pretty sure
Oh,
I put it
you
on there.
Yeah. Cause I have,
You done?
cause I think
Yeah.
that everything is in
Yeah, we're
kilometers.
Yeah.
Take a picture of it and scan so you don't forget. Don't forget.
Oh, I already took a picture. I'm gonna turn it on.
Yeah.
My car.
Don't forget.
Miss,
Because if you don't do it right now, you're gonna forget. And then you're not gonna get a full grade. You should.
I turned in all the missing stuff I had. I did. Hold on. It was not a while ago. It says I submitted them.
Because I looked. I'll look again.
Yeah, all the FOB stuff.
Oh my god.
miss,
Oh, you give it to me.
for like the paper one of the business that we did, like the other day. So like you could choose if you want to do A, B, or like.
I like
A.
sensing that comes.
So,
Is that why you?
like there was this one AP that we didn't talk about it yet, but I chose it because I knew what it was because it was supposed to be about like break even, and we haven't talked about it yet, but I knew what it was because my mom had a bus, has a bus business,
Oh,
and that one time I asked my dad how I was doing, and then yeah, and then she said, yeah, I was shocked. Yeah, and then I told her the whole story. And I also went to like a class of entrepreneurship, and we showed them about that surgery. Yeah.
Surgery. Wow. Surgery removed.
Bye, have a great day. See you next week. Study for the next mini assessment.
Yes, study. How could you don't study?
Mini assessment.
Maybe assessment.
Yeah, so what they're doing right now, we're in the organic chemistry reaction. They're doing 9 mini assessments over like 4 weeks. So most class periods, but not everyone. And taking the highest 6 scores to average the test. So they can drop 3. But also, if they get an 80% or higher average on the top scores, I'm bringing them up. So, study for your mini assessment. It's like 10 question quiz at the end.
Is this right?
What they're doing.
Wait, what is even organic chemistry anyways?
It's the study of like carbon-based chemistry, so it's like drugs and medicine and stuff like that.
Oh, and like,
We're gonna look at what it is.
So it's like reactions.
It's our final
with
unit.
carbon.
oh,
Yeah, reaction with carbon. We're gonna look at what it is by the end of the year, but we're only gonna do like how to draw them and how to identify them properly. We're not gonna do like all the reactions and stuff.
Yeah.
We only do like naming. I try to I was telling you guys in class earlier, I try to keep the end of the year not stressful. Like, we're gonna do these math units and then the last thing won't be too terrible. At least most people don't hate it that I've met. Most students are like, this is good.
no significant figures.
It's not significant figures. I told you, she just yelled out, I hate significant figures.
I hate.
Like, it wasn't even it wasn't a strong dislike. It was a literal hate of significant figures. I was like, okay. You're not the first one though, so it's okay.
It's so annoying.
Okay, the issue is that your conversion here is not much.
Yes.
Oh, it's meters?
Yeah, so it's
That's
SN
so
here, and then we did.
But look, it shows the KG thing, so you don't need
And
to.
like,
It does
that's fine. So what has to happen here? Instead of going feet to meters, we should be going feet to.
Oh, that's so easy.
centimeters.
Oh, yeah.
Feet to inch.
Feet to inches and inches to centimeters, yeah.
Oh.
Also, it's not easy, it's just KG to.
You're fine.
Wait, so she just did the whole lab instantly, like speed run it?
She did it in 6 minutes. I'll never forget it.
So she could have done it
Because
like
I just saw her
after.
working like super, super, super fast. Like it was the end of the Cambridge exam, and she just like you saw her eyes go bright because like you know when you made a mistake and you're like your eyes get real big, and then she was just and then writing, fixing all of that. Like she had all the processes, she just had to change the number.
Oh.
And so she did it in 6 minutes, and she got an A level, and I was like, that's the most clutch thing I've ever seen on a Cambridge exam. Clutch moment I've ever seen. They ended up with a B level. Their week paper was the multiple choice, that student. Like, they got an A level on the paper 2, which is the paper 3, which is the lab, but the multiple choice is the one.
Oh.
They got a good C on that.
Oh. Wait, it's only multiple choice?
There's a multiple choice test, yeah.
Oh.
There's a multiple choice, a written, and a lab.
Are those like really like the people who made it like think what you're gonna choose?
What?
Like remember, like it's not so easy to guess the right answer because.
Yeah, they say when I went to the training with the examiners, they said that they devise their questions in such a way that smart students will get thrown off. Like if you're just a good test taker, they'll intentionally put answers there to throw you off. Like if you use your regular test taking strategies.
Like sometimes I see like the trick of the question and like, aha, I got you. They try to cheat me, but I'm not gonna fall for it.
Cambridge does try to trick you. Like they sit there and one word will change everything. So if you don't read the question carefully, it changes everything. And the answer is not what you think it is. So that's where they're sneaky. They try to make a test that nobody can get a perfect score.
Oh.
That's what they try to do.
Nah, I'll get a perfect score. Just kidding.
I mean, we have had students at CIU get the top in the USA score in chemistry, so it's pretty good stuff.
Oh yeah, I got a.
Not top in the world, but top in the USA.
We were.
That's still pretty impressive.
Yeah. We were doing like a practice paper for history, and then he said that I got a C. I'm like, a C, and then like
C level.
yeah, and then he's like, oh wait, actually it's not that bad because you did everything I asked for. I'm like, oh.
Yeah. My target goal for students is typically to try to shoot for a C. There are some students that want to do like top in the USA or top, like, because it's a pride thing. Like, who doesn't want to say like I'm the best in the United States of America?
Did they get a trophy?
They did like a special certificate and recognition ceremony from Cambridge.
I'll put it like in my room. Like,
But who doesn't want to say that? But most students would be like, I just want to pass. But if you just want to pass, you don't want to shoot for an E because the E is really close to a not passing. So I always tell students, if you just want to pass, you should try for a C because that way you give yourself room for error. So if you're like averaging a C or a D level on your practices, I mean, you're most likely going
like,
to
I really don't want to pass. Just like I have the plot armor.
But if you're averaging an E,
You probably do.
you might do worse on the actual test because the thing about the actual test is that they're all new questions. You're more nervous, generally speaking.
Where do you take
so
it? Like in the school?
You take them in the school, yeah.
Yeah, you know that's.
And the lab you take right here. The nice thing about that is it's familiar environment, so you already know like with what you're working with.
And like does Cambridge tell you like the types of labs that?
Yeah, I mean, at the beginning of the year, we know all the potential types.
Oh,
So
so you
we
just
practice
practice all
all the different potential types.
Wait, so can't you just memorize all of them and then do
Well, I
it?
mean, the questions are unique every time.
Oh.
So, like, the
But, like, the
type
process,
of that, the
is the same?
process is similar, you just have to be able to solve for your unique situation.
Oh.
Like, they might give you something, a different color change that you're looking for, so you have to read the question. That's what I told you what happened with the girl. They said that there's always a trick in every test. That trick in their test was that there were 2 color changes. And she stopped at the first one. And then she realized when she read it, it looked like towards the end, her mistake, that they said look for the specific color change, and she had none. And she's like, I gotta do it again. I've never seen a titration done so quickly. Ever.
I just what I have to use the number line for that one.
Hey, this is.
Yeah, you should. Once you get to centimeters. Also, you have to do inches to centimeters, and then once you get to centimeters, you change centimeters to meters.
Oh, okay. So it would be 1.
No.
Okay, it's just like I get confused. I'm like,
That's why you're gonna have to spend time.
Inches.
That's what I was telling you about the bell works, is that they're gonna take time to do.
how much questions is it?
I have to relook at them. I'm
Oh,
gonna
I
look at
can
it
add
tonight
it to the
tomorrow.
quizzes still. I'm like, I made it to 30, but
That's more than half.
yeah, I did it in business like a few,
Okay.
but then we had to do stuff and then
You have to do work.
so I have to. Wait, I should.
Yeah, if you have friends who took this class, they'll know that this is the part of the year that it's the most work because it's math. Like,
Yeah.
math means you gotta practice.
Okay, that.
Let me just do the quiz.
Inches to
The
centimeters.
significant figures.
Significant figures.
I remember it.
Yeah, your class had a 94% average. I was like, what? Because the other classes were like 77 and
Bro.
74.
We are the best classmates.
Yeah, and I have the most game points.
Strongest pre-A's class. You are my best pre-A's class this year.
I have the most game points.
And competitive
And
people.
competitive, yeah. Even when Mr. Garcia came in, you guys didn't even know he was there. He was like, I can't believe it. Like, how invested they were.
I didn't even.
Oh, he was there watching me
They
do
were
the
like,
bell.
yeah.
Wait, the bell work?
You're better
Yeah.
than you speak from Kevin.
Not today. It was like,
Yeah, I was like,
2 months ago.
Yeah.
When he came in.
Wait, so he saw me.
He like commented like after class or something.
Yeah, of course. But he thought it was good.
Wait, so
I
he
told him
saw.
to come back because in my 6th grade that they were
It's
doing
like
a
a
lab.
show. It's like a show.
Oh, you could watch a show, stay for dinner and a show.
Stay.
No, I told them to come back for my base class subject to see they were doing a lab. So I was like, you're just seeing a regular lesson. Come back and see a lab.
Come back and see this period.
Not
Or
because,
period.
not because I didn't want them to see yours as well, but I'm like, that class, we're just doing the normal, which is good. We're doing the normal.
Like you saw
but
me hiding
if
the
you wanna
bicycle
see-
from Kevin.
Yeah, that's fine.
Oh.
That's why I didn't tell him he was there. I was like, he sees what he sees.
Like this is pure evidence.
We want
something.
We want them to know what happens in the school. Like,
Yeah.
here's your reality. Don't be fake. Don't
Right.
be fake. Just be yourself.
389.
You're not doing anything bad. Just
Wait, so why not 389?
289.
Yeah, correct.
Dito?
And yeah, correct. You guys are hanging good?
Wait,
The
and F?
pencil's lead broke like
What?
10
An
times.
F?
Yeah.
Oh no, I
But
forgot.
that was funny when
Oh,
we came
it's
to
like
the
this.
class and they didn't know.
It was like in the beginning of class.
These stuff.
Yeah, it was during the bell work.
No, I
And
understand.
they were like today, like now, like just talking, but like talking about the bell work.
Yeah.
Yes, I don't understand these.
Shouting out random numbers.
Somehow remember it's a double thing.
Level 1, yeah, so you guys said that.
But, like,
1.55 cans
this
divided by 1.
Okay, so like this one always goes to this one?
The top goes to the top, the bottom goes to the bottom. So the conversions you're doing is kilometers go to miles,
Oh.
minutes go to seconds.
Well, so it always goes to here.
It's so easy.
So you just gotta do one of them at a time.
Wait, so miles a second is just gonna be 1?
Well, you don't know what the number is for the top yet. You have to figure that out.
Oh.
Wait, so I have to convert
You
kilometers
have
to
to
miles?
change kilometers
yeah.
to miles.
Okay.
So you start with this, like this is your setup, what you have to do, but then you have to actually do it.
Significant
Not
figure.
there.
Should be 4, right?
Oh wait, actually, is it there?
Because there's no
He is
decimal.
King Humphrey.
King Humphrey? Is that, wait,
King Hoover.
wait, how are we supposed to make kilometers to miles?
There's
It shows miles. Wait,
It's on the other.
Oh, no, it's on the more complicated. Wait, I have to do the King Henry thing?
Oh.
Oh, wait, this wasn't, oh.
No, that's only some of it. They're all here.
A clock going on?
Wait, now what do I have to do?
Yeah, there's a stopwatch. It goes up for a minute, but just ignore it.
Oh.
Like I do. I forgot to do it.
Wait, now what do I do? So now my house is
So
second?
cancel out the kilometers, right?
Oh,
And then here, you need to put 1 minute on the bottom of kilometers, because it was kilometers for 1 minute. Like these two are attached to each other.
Then these two are attached?
No. The km/minute is attached on the same fraction. So 3.55 km on the top and 1 minute on the bottom, not just the number one.
Yeah, I like that.
Oh. And then you do your next one, you need to change minutes to seconds. You do multiplication, you gotta cancel.
Oh,
minutes.
So these go attached and then,
And then those two are attached at the end. not the percent.
oh, but then you have to do like the multiplication thingy to this one?
When you're converting top to top and bottom to bottom. Change the end.
Then I have to do 3.7.
Are you multitasking?
Yeah, kinda.
Left zeros don't count, so you start counting at the seven.
Oh, okay, so 2.
Wait, now I have 3.55 miles per each.
I hate
I'm not gonna forget that one. Just the expression, the honest expression of
Like,
frustration.
I was just doing my work and then significant. I hate significant.
But the funniest thing is that it's not the first time somebody has literally.
Like, it's not the first time. Oh,
It's the first time. And honestly, like, really, people who have done really well in chemistry, I mean, like, that's just the one topic that they're like, nope, not for me.
It's rules. Like, what is? It's rules. Like,
Oh, rules, yeah.
Like,
Aren't there a lot of rules in chemistry though? Like, this thing has its.
Yeah, but like,
it
significant figures is something else.
has something else, like, not these rules. Like, weren't there rules for oxidation numbers?
Yeah, but that's easy. Wait, okay, how are you
Or
supposed to
something
do
that
it?
figures it's difficult.
Okay, so look, you have to make the kilometer, look, these two go like in the same, like, look, there's the fraction sign. Yeah, that. And then look, kilometers to miles.
yeah, I'm like,
It's kilometers to miles.
like singing.
Oh, wait, this little thingy is a fraction sign.
Yes.
Oh, I didn't know. Wait, so what is, do we add another one?
Wait, why is there 60 minutes and 1 second?
Oops.
You're saying 1 second is still 1 hour.
One.
Time doesn't fly that fast. It's 60 seconds is 1 minute. Now, time isn't gonna be on here. That's the ones that you are expected to know. Cambridge doesn't give you.
The timer?
Yeah, you have to know
Oh,
60
yeah.
seconds in a minute, 60 minutes
Yeah, so
in an
that's
hour.
60 minutes in a second.
Hey. Wait, so now I have to do 1.61 to 6.
Remember, this was lesson 1.
From the very beginning.
Imagine the rest of the units. We haven't even done the chemistry yet. This is just the supporting math that you're supposed to already know. But in my experience, nobody does it fairly. Like, there were a few students that went, like, it also depends how many people took physical science. It's not a prerequisite for this class.
Oh yeah, I skipped physical science. We
But
skipped it.
If you had a good teacher for physical science, they teach all of
So
this stuff. Like, so that when you get to chemistry, you can just do it as it applies to chemistry. But because most people don't get that experience, I have to teach the stuff that you're
Yeah.
supposed to know, and then teach the chemistry that goes with it in pre-A. So that's why pre-A is like a super important class. So
Yeah.
most people don't skip days for that reason.
Yeah, like
Because in ACE, it's just like implied, you know how to do certain things.
I went to like I don't know what science. Oh yeah, literally, you know what my science teacher said in 8th grade?
What?
Okay, I was in high school. I told you it
Oh
was bad,
my
right?
goodness.
It was so dumb. Literally, I asked we were learning about photosynthesis, and the answer not even cellular respiration, just photosynthesis. And then literally she said, trees take in oxygen and release out CO2. And literally,
Does it cause global warming?
So then I told her,
So don't plant more trees.
like, I knew
So
that it was
everything we know is
opposite.
wrong.
I knew it was
Everything we
opposite.
know is
You know what I did? I tested her. I knew it was opposite, right? So I'm like, okay, so I'm gonna ask her, Miss, is this right? And I put her wrong version, and she said it was right, and I kept it like that.
Wait, so like, you do
I
this
felt bad
separately,
because I
then
watched middle school teachers teach before, and like,
do this
they
separately,
taught some
and
things
what
in
the
chemistry
heck?
that were like, they were teaching them
So
super
then you
wrong,
do this
like, they had no
separately.
idea what they were talking about, but I couldn't like correct them in the middle of class in front of the
Yeah.
I would feel really bad for that, being like, no, that's not.
Actually,
You get this. What the heck?
Yeah,
What do you do?
Because she didn't know what like
Yeah, this,
precipitate was, she didn't know what a
that,
homogeneous
this.
mixture
Yeah,
was,
so
she didn't know what a
just-
heterogeneous, yet she was like their science
Then
teacher.
you
And I was
get
like,
mad.
And what was she saying?
she said that the precipitate was something completely different, like it was like, you know, not what it was. And I was like, oh, wow. I can't remember now, but it was like, now I have to fix that. When they get to my class.
oh,
Like anything that they learned wrong, I'm like, I have to fix this now.
like, do you guys remember when your teacher that said that precipitate this was? Well,
They were wrong.
they were wrong.
And I can show you.
Where was the decimal, like?
Wait, you have to make this to this, and then make this times this.
Well, she's waiting.
Centimeters is right
It's just
here, and meters is here.
Oh,
Remember, it's
here.
single letter, so it's the unit. So you have two spots to the left,
But, to the left, so.
from the end of the number. So it's 9,144.
From here.
It would be from there to over.
Oh.
See, man, I confused on what I did.
Uh-oh. So you can answer.
Yeah, but like, I
You
forgot.
do
Like,
have the correct answer.
yeah, but I forgot like the process.
So,
Like
I
this
think
one.
you did it one step at a time.
No, but
No. What did you do? Oh,
what?
you have this divided by this, and you have the kilometers canceled, get a mile over a minute. So you just did one step, right? And then you have the numbers divided, 3.5 by 1, 3.5, and 1 second, 1. And then you said, so you basically broke it up in separate steps. You should put it. Then it comes this, yeah.
Oh,
And then you change minutes to seconds by putting 1 minute on the top and 60 seconds on the bottom. You cancel out your minutes, so this doesn't cancel the miles. You get miles over seconds. So your final answer is miles over seconds. The units that don't cancel. So your number's right, but you just have to write it miles at the top and seconds at the bottom.
and like
So
so.
it'd be miles and.
Well, how do you like start it?
What do you start?
The kilometer, yeah, like the kilometers has to be with this one.
Like this.
But like why like that?
Because it's like driving. You're driving that speed every minute. So when you're driving like in a car, and the car says 35, that's miles per hour.
Oh,
That's a double conversion. That means every hour that passes, you're driving 35 miles of distance. Here, you're driving every minute, or you're walking every minute, or whatever it is, 3.55 kilometers per minute, probably flying, because that's pretty far. 3.55 kilometers is a few miles. So you're
Okay,
going,
so-
you're driving.
so these two have to like be in a fraction together, and
Yeah,
then
they have to be
these two have to be in a
because they're
fraction.
connected. You're driving or you're flying that much kilometers every single minute.
But then, why does it convert to miles?
Because they're just saying, we want to know how many miles that would be every second. So how many miles would be
Oh,
every second. So
Look,
we could have changed this to miles per hour.
yeah.
How many miles per hour
Look.
is that?
It's because these two are fractions, and then this one says 2 miles per second.
Right, it's
Like
going
kilometers
to
per
that.
minute, 2 miles per second.
So,
So you have to convert it.
kilometers into miles.
No, it has to be this, and then
If the top
this.
goes to the top.
So what you did?
He broke it up into separate steps.
Hey, how am I supposed to do it?
I'm gonna show you how I would have done it, is I would have done 3.55 km over 1 minute times, like you did, 1.61 km, 1 mile, cancel out km, times 1 minute, 60 seconds.
Oh,
Equals, cancel, multiply across, and then divide. So this would still give me 3.55 over 96.6, and miles is on the top, and second form of oxygen. That's how it goes.
Wait, so you can just do the setup already?
Yeah.
Oh,
So say you could say this over.
wait, so you can do the setup and then solve it?
Mhm.
Oh, because I did this. Hey, I'm gonna find the second fraction. It's the miles
The
over.
first one, miles to kilometers.
Then say miles second.
You only do the top part first. So you can't incorporate both into the same fraction. You can only change kilometers to miles or minutes to seconds. You have to do
So,
them as separate parts.
You have to do, look, you're basing out the kilometers here, and then here, and then, so you can turn kilometers
Kilometers
into
to miles,
miles.
and that takes care of the top part for you. So check mark that into the first fraction. Then the second one is to get you from minutes to seconds. Because you, even though the top part's correct, you change kilometers to miles, you still have to change minutes to seconds.
Oh, so you have to, maybe.
So the first conversion was to do the top, and the second conversion was
Oh, Miss, how much significant figures in this one? Like,
all of them.
all of them?
Yeah, because the decimal at the end says that everything's important.
Oh, so it's like.
Well, we have to go.
Okay, you almost got it all in.
Yeah.
Congratulations.
I finished the
Math.
homework.
Yay!
Finally.
All right, it's time to go anyways. It is time to go anyways.
Yeah.
Let's see. It's like some of my students in second period have math like directly after chemistry, and I was like, oh, that sucks. Math, then math.
I have chemistry, and then on another day I have math.
And some students have 2 math classes.
Oh, like foundation?
Yeah.
Yeah.
And then they're taking chemistry. So they have math, then math, then math. Can you imagine that? That's
insane.
it hurts.
That hurts.
Like, okay, got that. And then you got a little bit of math, and then double math.
So basically the whole day.
The whole day's math.
Yeah, because there's only 3 classes, right?
Yeah, you only get 3-day classes, so you get no break from math.
Literally the whole
You just have
day is math.
all day math. And you know, math classes are like, you know, you do math the whole time.
And then after that, you have to do math homework.
And then you have math
Oh,
homework.
I have to go this way.
That's rough. I don't know, like, unless you love math, you know.
At least you do that now.
Bye.
Bye.